स्टार्ट करी कहाँ तक ले जाना है थोड़ा मिड लेवल पे भी और
अच्छा सीमेंट का कुछ हैंड्स ऑन किया है
एक हैंड्स ऑन करा दी थोड़ा सा डॉट के रात से बता दिया टीम की पास
तो वो सीएनएन होगा अगला क्या बीच में क्या डाला था रेलो ड्रॉप आउट कुछ
रेलो कूलिंग नेक्स्ट कूलिंग और फिर ड्रॉप आउट
फाइनल एफसी में
एफसी फिर पूरी कनेक्टेड कर
बीच में ड्रॉप आउट
कोई ड्रॉप आउट मतलब ऐसे आधे घंटे में मैंने तो बस कर दी वो इतना डिटेल में और प्रोपोगेशन तो बताइए आपको पास जानता ना
अच्छा
पहले हो गया
ठीक है तो हैंड्स ऑन हो जाता होगा थोड़ा
हाँ
मजा आता है
सर अच्छा है मतलब कल मैंने बहुत कुछ बता दिया तो
ठीक है हो गया
Okay, so good morning all and welcome to the day 5 of this SERB sponsored workshop on AI and machine learning application in healthcare. So it's my immense pleasure to introduce our keynote speaker, Dr. Munendra Ojha. Dr. Ojha is Assistant Professor in Department of Information Technology in the Indian Institute of Information Technology, Allahabad. He has completed his MSc degree in the Computer Science from Banaras Hindu University in 2004. MSy Research in Computer Science from University of Missouri, Columbia in 2009. PhD degree in Computer Science and Engineering from IIIT Allahabad in 2017. He has published various research articles and many journals and conferences. He has taught various courses like the artificial intelligence, deep learning, natural language processing, data mining, etc. His research interest includes the deep learning, machine learning, natural language processing, video analytics, semantic web, multi-objective optimization, genetic algorithm, multi-agent system. So this was just a brief bio about his tremendous work experience. Now may I invite Dr. Munendra Ojha sir to deliver his talk. Sir, please sir.
फॉरवर्ड पूरा
Good morning, everyone. As introduced, I'm Dr. Munendra Ojha. I'm coming here from IIIT Allahabad. I've previously worked for a very lovable time of 5 years at IIIT NR. So, kind of coming back to my family, my home. And in this lecture, I would like to introduce you to neural network. And probably I've heard that you guys have already had an introduction of neural network yesterday. So probably I'll start from that level of introduction and get into a deeper version of what are neural networks, what they do and how they do. And then from there onwards, I will take you to the journey of CNN, the theoretical concept of convolutional neural network. Okay. And you already have done some kind of hands-on yesterday. So it will be better to relate to that hands-on and you will be able to ask questions. And at this point, I would expect you guys to ask question, because once you ask question, then we come to understand what is getting through, and then we can explain in a better way, and probably will be able to explain and what neural networks, what convolutional neural networks are, and you would enjoy this talk, right? So consider this talk not as a keynote address, but as a theoretical class, because I would prefer to be explaining the core concept rather than just going through the cursory introduction. All right. Okay. A brief history, backlog and pits. So these are the guys who introduced a first neural network. Okay. And this network was a binary classifier. It was capable of recognizing two categories based on some input. So it was able to differentiate. And when it was able to differentiate, you understand the model, the type of model we are trying to refer to is a classification model. It is trying to distinguish between two classes, class 0, 1, class -1, class +1, class yes, no, class false, true, class success or failure, binary classification, right? So the basis of this is classification. And neural network is also a great classifier. We don't dwell into regression part. I think till now you have a fair idea of what is supervised learning, unsupervised learning, within supervised classification and regression, etc. So model was purely based on mathematics and algorithm and couldn't be tested due to lack of computational resources. However, the perceptron algorithm was published by Frank Rosenblatt, and this model could automatically learn the weights required to classify an input, and no human intervention was required. Now over here, I think you already have some idea of what am I talking about when I consider weight value. The biggest thing to consider over here is this is the equation, this is the formula, this is the mathematical expression that we will all be referring to all the time. Okay, fx equal to wx plus p. And over here, what is fx? Can anyone tell me what is fx? Huh? It's a function. To do what? Function of x, of course. Other than that, what is the significance of it? Activation function. Accuracy. Anyone else? It's the model, right? It's the model itself. It's the machine learning model that we are trying to create. So whenever we talk about machine learning, we say that we are going to create a model. We don't create something tangible, जिसको आप छू सके, पकड़ सके, तोड़ सके, मरोड़ सके. This is the fictitious, untouchable, virtual model. That is what we are trying to find out. How this function would look like, that is what we are trying to find out. It may be, and as we are all aware with mathematics, we know the function could have any degree 1, degree 2, it could be linear, it could be non-linear. ठीक है, ये तो होगा, इससे ज़्यादा तो कुछ नहीं होगा. If it is linear functions, then probably there will be a line, there will be a plane, there will be a hyperplane. ठीक है, अगर linear नहीं होगा, it will be non-linear. So, this function will not be anything other than linear or non, right? Supposedly this is linear function because there is some power. Power is 1. ठीक है? If power is not we get into higher dimension, it will become a plane and then hyperplane, but it will remain linear. So at this point, for the sake of simplicity, I'm just considering linear functions only. I'm considering function to be got a degree of 1, not more. And eventually, I will come to a point where linear function will not be sufficient. I will have to create a non-linear function. But at this point, I'm starting with a linear function. And this is also the function of regression, linear regression. Probably if that was discussed in the course of this workshop, this is also the function of linear regression. If I could expand this, you would understand that instead of having one weight value, I can expand this input to have multiple weight value W1 X1 plus WX dot WD plus D. So this input X has got D feature values, and for every feature value, I have a corresponding weightage associated. All right, and this is the function of regression function, right? If we have to optimize that regression function, we have to find out this, and it is still equal to. So we start from here and we try to find out the best regressor. Okay. So if I'm trying to find out the best regressor from this function, what is known to you? If I talk about this function, what is known to you in this function? X is known to you because that is the input. And if it is a classification problem or a regression problem, what is also known to you apart from input X? The target Y, right? So X and Y are known to you. Now this is X that I've already utilized. I'm trying to find out Y, which would be equal or very similar to X. That is what I'm trying to establish. So I'm being given X. With X, I have to find something that is very closely related to Y. Okay, this something is something that I'm trying to find out. और ये something मिलेगा कैसे? हम क्या करेंगे? हर बार X की एक value put करेंगे. We'll put the value of X every time on the right hand side and modify these values of W1, WD up to W1, W2 up to WD. Every time tweaking W1, W2 parameter such that this fx gets closer and closer and closer to y. Okay? Okay? It's just like teaching a kid. When a kid is there, right? When a kid is born, the neural network in the brain is untrained, very biased, like a clean slate. We feed information to the kid. How? With experience. Every experience that kid has is kind of an input that is provided to the kid. All these values are okay. Sometimes the kid would look at their parent, the mother, the father, the uncles, sisters, brothers, etc. And the kid would see their faces. Right? All right. And what are these faces? These faces are input values. And it would not happen immediately that a kid starts recognizing an unknown person. It would take a certain amount of time. Suppose I want to train a kid on recognizing certain face. Okay. So suppose I want to train up my kid on the face of, let's say, Barack Obama, that this is Barack Obama. He would not have seen Barack Obama. Okay, but I want to train my kid. So what I would do, I would show the face of Barack Obama all the time and tell my kid, this is Barack Obama. So what I did, I presented an input function, input X as a photograph, and then gave it a label, Y, the name. All right. But kid's brain would get an input. And the brain would do something, alter these, right? Do something. So X value is fixed, that's the photograph. Y value is fixed, that's the label, Barack Obama, name. But what is changing in the brain? These W values. Right? W values are changing. And what the kid is doing, trying to remember. So the kid is creating some kind of function fx, which when fed this X, the input image, tries to produce Y, which is Barack Obama. And every time I show the image and ask the kid, "Beta, ye Barack Obama." It's learning something. Okay? So would it happen that kid would start recognizing Barack Obama at the first try? No. At the first attempt? No. It would take some time, take some iteration. Again and again and again. Barack Obama छोड़ दीजिए, हम अपने father को ही अगर kid को recognize करना है, तो it would take some time. Probably mothers are the only relation that kid would be able to recognize, not by the face, but by the natural instincts, by the smell, by the whole creation of the nature, right? Other than mother, every other face the kid needs to remember, right? The kid needs to remember, the kid needs to modify these W weightage values in the brain. That's the neural network, natural neural network. And this is what is happening. We train the kid again and again in an iterative manner. By the time that newborn kid starts to speak first word which we could recognize, how much time duration that would be? Suppose there is a newborn kid, okay? What do you think? What is the time duration after which this kid would utter the first recognizable word? Let's say mama or daddy or papa or whatever. These are the first words that we are able to identify. अरे मेरे बेटे ने पापा बोला. ठीक है? कितना टाइम लगता है? 3 months. 6 to 7 to 8 months, right? So let's say 6 months. So 6 months of training, 24/7. Okay? I'm forgetting that nature says, the biology says that kids start learning in the womb itself. So the moment the kid is born, 6 months of 24/7 training, this brain which is nature created has got 11 billion neurons. It requires 6 months of continuous training to speak first word that we are able to identify. Of course, it's not only this training to say the word that is happening. There are a lot of things which are being fed to the brain continuously. But पहला recognizable output, जिसमें error maybe acceptable 0 है, 0 नहीं है, but हमारे acceptable threshold है कि हम उसको recognize कर लेने के अरे पापा बोला, ठीक है? 6 महीने लगे. इस neural network को कितना टाइम लगता है? 2 मिनट में एक्सपेक्ट करते हैं कि अरे हमारा रिजल्ट नहीं आ रहा, एरर इतनी ज्यादा है ना? Okay. So this is also neural network. This is a model. All we are trying to do is the nature by creating very simple function fx, बहुत simple से parameters हैं, and these are the parameters W values which we need to learn to create this model fx. Fx would be the first word uttered by that kid. और हम fx को y से हर बार मैच करेंगे. वो पा भी बोलेगा तो अरे रे पापा बोला नहीं, फिर हम हर बार मैच करते हैं. जिस दिन हमें लग जाए कि हाँ आज उसने पापा बोला, मैं संतुष्ट हूँ, तो दैट इज द थ्रेशोल्ड दैट आई एम एक्सेप्टेबल टू लिव विद. कि मेरा एरर fx का y से जो कंपेयर करते आ रहे हैं, ये एरर एक्सेप्टेबल थ्रेशोल्ड नहीं. तो एरर 10 to power -2 हो गया, तो हमने कहा कि हाँ हमारा एरर बहुत अच्छा हो गया. दिस इज एन एक्सेप्टेबल लिमिट दैट आई कैन लिव विद. माय मॉडल इज परफॉर्मिंग एज पर माय एक्सपेक्टेशन. दैट इज व्हाट हैपेंस इन ऑल. वी स्टार्ट विद अ रैंडम simple function, then try to feed x value every time. After feeding x value, we generate fx, compare fx with y, calculate the loss, the error, the difference, the risk, whatever you need it, and then that loss value or the error value is propagated backward so that w value can be modified. W and b, these are parameters. So we modify these parameters. ठीक है? कब तक मॉडिफाई करते जाते हैं? जितना देर ट्रेनिंग चलेगी. और जब तक this difference is not within our acceptable limit. हमें acceptable होना चाहिए. अब 10 to power 3 है, that is not it. Okay? But 10 to power -3 is 3. But 10 to power -3 is not 0. We all understand, right? But that is acceptable. So we say when fx is very close to y, that means that error is very low, accuracy is very high, and the model is performing as per my. यही है पूरे मशीन लर्निंग का लक्ष्य. मशीन लर्निंग में we are doing the same thing, okay, all the time. Now, what is in neural network? in neural network, there are a lot of different small models which are trying to work in parallel, work in coordination, work together to create a whole big model. Big. Instead of this small effect, there would be thousands of, hundreds of thousands of which will be working together to create a big X, that's a GX. Okay, and that GX will help me solve multiple problems, right? Because since we have got 11 billion neurons and every neuron is doing some functionality, similarly we are trying to create millions of neurons who are working together, sometimes against each other, sometimes working, sometimes not working. जैसे हमारे ब्रेन में है ना, कहते हैं ना हम 4% ही अपना ब्रेन यूटिलाइज करते हैं, तो 96% तो वेस्ट पड़ा हुआ है, उसको भी यूटिलाइज नहीं कर रहा है. अगर कोई यूटिलाइज कर रहा है तो इट मींस दैट इज आल्सो यूजेबल, but at this point of time whatever we are doing, we are 4% is sufficient to do that. Similarly, the neural network that you create, it is not important that you utilize all the neurons. What is important is whatever neuron you are utilizing are able to give you the proper. Okay. Any question till this point? So, okay. So I expanded W. All right. What is the B doing? What is B? Bias. Right? Why am I putting this bias here? What is the significance of bias? Everything is nature inspired. I gave you the logic. Why X and why W? Because X has got certain parameters, certain features, X1, X2, X3. And features means what? Let's say if I have to identify, let's say, Professor Anurag. So how do I recognize Professor Anurag? Professor Anurag has got certain features, right? His name, one thing. His facial features are another thing. His mobile number is also one thing. His family, his friends, number of boyfriends, number of girlfriends, right? Of Professor Anurag. All these things are features which are associated with Professor Anurag. So how do we recognize him? What is important, what is not? All these things are related. Okay? But what is important, what is not? If I have to identify how to identify Professor Anurag, right? So probably facial feature, if I start describing, will there be any end to the facial feature that I describe for Professor Anurag? As per my understanding, you keep on explaining whatever you know about him, but a person sitting opposite to you will not be able to draw the exact photograph of Professor Anurag. Will you be able to? If whatever you try to explain. Similarly, suppose what's your name? Elizabeth, and you are doing PhD. Great. So you must have some courses to study, right? So if I have to estimate what would be the CGPA of Elizabeth, then what would be the input that I feed? Let's say the name, okay, is one feature. First name, last name, I can divide it into two features. Then mobile number, then probably parent, what her father is doing, what her mother is doing, how many friends she has. But do you think these features has any relation to the CGPA that she will have? If I say how many social network friends she has got, might be an indicator of how active she is on social network, and that is inversely proportional to how much CGPA she is earning, right? If probably suppose Elizabeth is very busy on social network, then her CGPA will come down. If she has got so many friends, she has to maintain such a big, huge friendly network, her CGPA might go down. If she has very few selected friends, of course, she is not wasting time in doing networking. Her CGPA may be an indicator. It might be an indicator that CGPA may go up. But what about her mobile number? Her mobile number is a unique feature associated with Elizabeth only. This mobile number will not be associated with anyone else. Very unique identification, right? But does it have any relation with how much CGPA she will have? Not at all. But all these are input values. So suppose I input value X1 as a mobile number. What should be the weightage of this X1 mobile number? Because this is not going to help me in understand what will be her CGPA. Okay? Number of friends may be a feature which might have a, but mobile number is totally used. Okay. But these are input values. The value with which we recognize the input, value with which we recognize the input. So there will be different weightage for all these features, all these properties. But these are known values. Bias. You say B is greater, I get biased towards an input value. Okay, that is well known. But what is value of what is the significance of this B over here? What is it doing in this input along with input? Anyone? Because here on the right hand side, all I am doing is feeding input. आपने जब बच्चे को बराक ओबामा की फोटो दिखाई थी, was there a bias associated with that? Along with that image, was there something more? There was nothing more. So what is it doing over here? Any idea? Any guess? Any random thought? No thought is a bad thought. Everything has a repercussion. If I get your thought, then I will be able to modify my way of expressing in a better manner. I'm also a machine learning model. You tune me, I'll get better. You don't tune me, I will get random. I'll generate random result. You will not be able to understand what I'm generating. Right? So audience tunes the speaker. आप लोग चुप रहोगे, कोई इनपुट नहीं मिलेगा तो मैं एकदम रैंडम, एकदम अंडर फिटिंग मॉडल बन के जाऊंगा, किसी को नहीं समझ में आएगा क्या बोल रहा है. ठीक है? And if you want me to explain to the maximum possible, I will be overfitting model. Generalization नहीं होगा. I will be very specific example. और हो सकता है जितना मैं पढ़ाऊं बाहर निकलते ही उसका कोई रेलेवेंस ना हो. आप मेरी नॉलेज को जनरलाइज नहीं कर पाएंगे. That will be overfitting model. So you need to tune me so that I am balanced between underfitting and overfitting. Any idea? Any random thought? What is B doing? Huh? Prior knowledge. It is knowledge. Prior, okay, I'll relate to that word prior later. Anyone else? Unique feature. Right? But that is known. So that is a feature that goes into it. Okay. Class comes over here. That is a target that I have to achieve. Okay. As I gave the example of Professor Andra, I try to explain how he looks like, what he is, how great his personality is. But whatever I say about him, भगवान के बारे में कितना भी बोले कम है ना. Whatever you have, whatever information you have about anything, any experience, आप बाहर जाइए, ठीक, आपने सपोज आप बाहर गए, आपने देखा कि किसी को किसी गाय ने मार दिया, इट इज वेरी कॉमन, राइट? क्या आप बाहर जा रहे हैं, हमने देखा किसी ने गाय को मार दिया, गाय ने किसी को मार दिया, ये लड़ाई चलती रहती है. And you come back and you try to explain that event. Is there anyone who will be able to explain the whole event, the maximum नहीं, to the last detail possible? आप पूरा ऐसा आप एक्सप्लेन करिए कि वो पूरा किसी को लगे कि हाँ हम सामने देख रहे हैं बैठ के. No, not possible. ठीक है? तो where are we lacking? We provide information. We provide it, and all that information that we remember, we provide. But howsoever detailed information we try to deliver, there is something which is missing. This missing is always. Even if, as I said, it is not, it is very close to 0, 10 to the power minus 3 information is missing. But it is still there is something missing. So, when the information is missed, what are X values? X values are observations. Most of the time we say statistic, observation, dependent observation, dependent data point, dependent values. All these are observed. So you observe something, you try to explain, that is expressed as known, what you know. And somebody came to me, somebody expressed that. I registered, I recorded all the known, but still there is something unknown that I do not know, that was not told to me. That is attributed to me. So bias is a measurement of unknown. Very simple as that. Bias has other properties as well. Bias tells you that my system is maybe biased towards some kind of property, maybe biased against some kind of property. That is a side effect. But overall, when I include it in this right hand side, this right hand side is complete picture. Why I'm saying complete picture? Because X is something that I know and is recorded. All right, X is recorded. B is something that I do not know is not recorded. And combining the known and unknown makes it a complete picture. So how do I know what I do not know? By mathematics, right? So मैं कितना भी x दे दूं, x की वैल्यू कितनी भी दे दूं, x1, x2, x3, x3, xd, कितनी भी x's दे दें, क्या होगा? It is all known, but still something is missing. कुछ missing है, right? That missing is taken care by b. All right. So right hand side is a balance between known plus unknown. Known and unknown, and known and unknown makes you add it together, it becomes the complete picture, the whole picture. All right. So if known goes down, unknown increase, because known plus unknown is constant. If knowledge goes down, this work increase. Rumor वहीं फैलता है जहां ज्ञान की कमी, ठीक है, right? So you do not know the fact, and what is not fact is fake. So rumors increase when knowledge known item is less. Known goes down, unknown goes up. That makes an underfitting. For example, suppose someone is, how do you explain a tree? There are a lot of trees over here, very beautiful place. You would have seen tree, okay? And you go to Allahabad and you say, I have seen a very beautiful tree. They would say, what is a tree? We haven't seen a tree. हमारे चारों तरफ तो सारी सिर्फ गाड़ियां हैं, लोग हैं, बिल्डिंग है, घर है, झोपड़ी पट्टी, यही सब है. There's no greenery, almost no greenery. I don't call that a greenery when I go back from Raipur. So how do you explain a tree to an Allahabad? It should be green above and brown below. Is it a tree? तो कोई भी अगर ग्रीन शर्ट पहनेगा और ब्राउन पैंट पहनेगा तो ट्री हो जाएगा, नहीं होगा ना, राइट? दैट इज एन अंडरफिटिंग मॉडल. छोटा सा आपने नोन बड़ा छोटा सा कर दिया और छोटे में आपने लेटा दिया बंदे को, यही ट्री होता है जॉर्डन. तो नोन कम होगा, अब अननोन बहुत बढ़ गया. वेरी अंडरफिटिंग मॉडल, कुछ नहीं बता सकता, बट वेरी सिंपल. Okay, simplicity is good, but simplicity also should have a lower limit. ऐसा ना हो कोई भी आपको फायदा उठा ले. It should not be very simple. We increase the amount of known quantity. So आप start करते हैं करना. नहीं, what is below is brown, but that is called trunk. It should have this length and this girth. This thickness should have some branches, should have some roots, and should have some branches. Okay. And the above canopy is green, but that is not totally painted green. There are leaves, these leaves, that leaves. So how many leaves? There are bushes also. Bushes also have got leaves, but bushes will not become tree. So you make a different tree. Trees have got these many leaves and that many leaves, like that. So from the very simple model, when the known entity is very low and unknown is high, you move towards a model in which known quantity is more and unknown is right. But आप उधर move करते at a time you reach कि नहीं, you are not able to get it. A tree has 4,360 leaves, 25 branches, and probably 40-45 roots. Is it a good tree explanation? If I am not able to find that tree, so every tree will not be counted as tree. And suppose the tree that you are explaining to me has accidentally a leaf fallen down, then again that will not be. There won't be a tree that you explained. उसका तो एक लीफ कम हो गया. So that is overfitting model. कुछ ज्यादा ही पढ़ाते हैं, ठीक है? तो the machine learning models average balance between the two extremes of underfitting and overfitting. इसके बीच में कहीं कोई. So that I give you an idea, I give you a perception. मैं आपको एक image create करके दूंगा, which is a generic image, and you go out of this room and you are able to apply it to neural network, to natural language processing, to image processing, to video processing, to any damn field. बट अगर मैंने सिर्फ यही बताया कि कैसे न्यूरल नेटवर्क सिर्फ इमेज पे लगेगा जो कि मैं करने जा रहा हूँ, तो अब you will be limited to image only, right? But the idea is I should have a knowledge which I'm able to apply to any field of application. ठीक? It's machine learning is set of algorithm. It's like a tool. अगर आपको हमने हथौड़ा दिया तो आप एक हथौड़े से क्या कर सकते हो? With the hammer, what you can do? Creating a fine ornament or probably destroying whole building. दोनों काम कर सकते हैं. But creating a fine ornament, the hammer that I'm going to use to create a fine ornament will not be utilized in destroying a whole building. And the hammer that I'm going to use, the sledgehammer, cannot be used to create a fine ornament. So it's a tool. How do you tweak that tool? How do you modify that tool to do what is up to you? And that comes out of experience. We cannot teach, you cannot train, no one can do. It comes out of experience. You can just tell you there is a hammer that has got this property. You can beat something out of it, and then it could be utilized like this. It could be created. That's all. One should do. Okay. And how you apply, how you take that knowledge and generalize it to your specific domain is your expertise, your experience. Once you start doing it, then you will come. All right. So this balance between known and unknown is very important. If X increases, known is increasing, it's going down. Okay, bias is going down. When bias is going down, unknown is down. That is a model that we require. But when bias is very low, we don't have anything unknown. सब कुछ बता दिया. किसी बंदे को अगर एक्सप्लेन करना है तो उसके सर पे कितने बाल हैं, उसके मुंह पे कितने बाल हैं, उसके हेयर फेशियल हेयर कितने हैं. These things are not at all required, right? Like a tree. All these things are not required. You just explain a person such that that could be generalized. So that becomes, if unknown goes down, it is leading towards overfitting. And if known goes down, that is leading towards underfitting. हमें इनके बीच में रहना होता है. A perfect machine learning model is a balance between these two extremes. So B, bias is the kind of measurement of unknown, what is not known. And apart from that, mathematically there is. So what we are doing when we are trying to create the machine learning model is trying to find out the value of these parameters. Okay, these are parameters. These are learnable parameters. Have you heard of the term hyperparameter? There is a term called hyperparameter, right? And hyperparameter tuning is very important, of utmost importance in when you try to create a machine learning. If these are parameters that you are trying to learn through the training of ML model, what is hyperparameter? Optimization is again a set of algorithms that we apply to tune these hyperparameters. But what is hyperparameter? What are we trying to tune? Are these hyperparameters? No, they are simple parameters. Then these are parameters. Then what is hyperparameter? Hyperparameter, as the name suggests, should be something above parameters. Definitely very sensitive because that is very hidden. No, actually they are not hidden. They are very visible. Hyperparameters are very visible and they have a strong effect on what will happen in the algorithm. How this algorithm will perform very closely. Hyperparameters are all those parameters that you need to set before you create them. Okay? Before creating the model, all those parameter values, forget about parameters, all those values that you need to decide upon are hyperparameters. Like if you will discuss neural network, you have already done neural network, right? कल किया था CNN किया था ना? How many layers of CNN you created in the model? How many layers you called? 2D CNN कॉल किया होगा ना? कितने लेयर बनाए थे? 4 layers. Why 4? It's the hyperparameter. Before creating the model, you first identified or you first decided that you will create 4 layers of string. One layer, कौन 2D करके create किया होगा ना, तो कौन 2D कितने कॉल करने हैं, 4 किया, क्यों किया, 5 क्यों नहीं किया, 3 क्यों नहीं किया, 4000 क्यों नहीं किया, नहीं किया, नहीं किया. But this is the hyperparameter. You decided. How you decided? I'll come to that. But somehow you decided on this value. Okay. Then how many filters were there? How many filters in each layer? One layer. Again, this is the hyperparameter. Decided with the value and you started that. So before the model could start training, जो कुछ आपने decide करके उसमें implement कर दिया, all those are hyperparameters. How do we get those values? Basic rule of thumb is we start by studying the literature. And by literature review is the first step in research. Okay, we learn from our predecessor. We learn from the experts who have already done this. So what I'll do, I'll read some paper in which they would have started with some hyperparameters. Like the first one was AlexNet 2012, Alex Krzyzewski and Geoffrey Hinton gave this AlexNet, right? That was the advent of CNN. 2012 में जब AlexNet आया तो तभी से तो हमारा CNN start हुआ है. और deep learning का जो beginning है, it's credited to them only. So I will look at AlexNet and I will see how many layers they have used, what are the number of features they have used, and that I will start with. For my model, for my data, probably I will start from their network and tune it a bit. So that for my data, it is giving me best thing, the AlexNet. Okay. Why AlexNet? You can start with anything. You can start with BGG, you can start with Inception, you can start with Google and anything. It's up to you. Again, a hyperparameter. That's your choice. See, then Scratch does not have any foundation, has not a proven legacy. Okay. We don't start from scratch because that does not have a proven legacy. Everybody will ask you this question, why did you start from scratch? You already had proven algorithms, proven models, which were working so beautifully on these kind of data. So why did you start from here? Can you prove it? You will never be able to. Okay. So we don't start from scratch. Taking help of our superiors, giants who have already proven things is the best, simplest way to start. Okay. So you start from literature, take a model from literature and start from it. Tune it according to your data, right? After tuning, I think that's not. So after tuning, this model, which will start working for your data, will be called a baseline. This model will be called a baseline. Now, baseline is not AlexNet. Baseline is the AlexNet that you tuned those hyperparameters for your problem, and it is giving the best result for your problem. It is not your model. It is not your model. It's just AlexNet that you borrowed, give reference to Alex Krzyzewski and Geoffrey Hinton, and then tune those parameters. Like suppose उसने 36 filter लगाया है, you put 40 filter, you 30 filter, and you tune it somehow. All right, and tune according to your data and say that AlexNet is giving the best result on these set of values, and from here I'm starting. I will call it a base. Once you decide upon baseline, then you start making changes to the model itself. अभी तक क्या कर रहे थे? Layers बढ़ा रहे थे, घटा रहे थे, और filters बढ़ा रहे थे, घटा रहे थे. उससे AlexNet को थोड़ा सा modify करके it created a new model, a new set of hyperparameters, same model, and I called it a baseline. So baseline will be the minimum accuracy with which I will start. And when I'm doing research, I will create a new model, new algorithm, new deep net, which will be better in terms of accuracy than this. That is my task as a research. Okay. So whatever you want to do, you start with a basic baseline, and from there you start modifying the algorithm, try to invent something, try to discover something, try to put in some new idea, create a new algorithm, and test it against the baseline, test it against the state of art algorithm, and prove that your model performs better than them and that is sufficient to publish it. ठीक है? Research इसी तरह चलता है step by step. Okay. So I have said too much without any. Yeah. Very simple. We draw validation versus training curve, and training curve accuracy, training curve error goes like this. Okay, and there is another term called validation accuracy. Continuous validation. Validation accuracy goes like this. Okay, so gradually as the time progresses, the more and more data you feed to your model, training accuracy, training loss decreases. ठीक है, accuracy increases. और अगर accuracy की बात करें तो this will be kind of training accuracy ऐसे जाएगा. और validation accuracy कैसे जाएगा? Validation accuracy नीचे ऊपर रह सकता है, but it will saturate. And this gap increases. चाहे ये gap हो चाहे ये gap. Okay. So validation is one thing with which you actually ascertain how good your model is performing. Okay. Now I have another question. All of you are machine learning experts, right? Today is the 5th day. So in 4 days, you already become machine learning expert. Now is the time of deep learning. What is the difference between validation and testing? Behavior of the model. And what about validation? That is how we are going to do. So why this segregation? That can also be called testing accuracy. Can I just take a break for 1 minute? Okay, so validation is something that we use to tune our model at the time of training itself. Okay, like and what is the use of that? Once I'm done with training, so at the time of testing, I won't be able to change the model. I won't be able to modify the model. So what is the benefit? अगर training के time ही मुझे पता चले कि this is the error that is happening, so I might tweak the model. कुछ training अलग से करेंगे. जब सब कुछ बीत गया, तो फिर फायदा है. Testing at the time of testing, it's only testing. There is no modification involved. Okay, we cannot change the model. It's like your examination, the classes you have, the courses you have. Okay, there will be a lot of professors who will be teaching you. In the class, they teach something and then ask question. Okay, like I'm doing over here. I'm telling you something, then I'm asking question. I'm telling you something, then I'm asking question. This is validation. I'm trying to validate whether my information that I'm passing to you is actually going through to you or not, or how good am I delivering it. So if you are not able to respond, it means I am a useless person. I am not able to train you. So I tune myself. मैं अपने को modify करना, मेरा method modify हो गया. Suppose my speed is too fast, I'll slow down. Let us stop. Let us think. Let us repeat. Okay. At the time of training, in the classroom. So whatever question I'm asking here is not your testing. just my validation. Models training validation. How good the training is. But there will be a time when semester ends and some exam आ गए. At that time there won't be any classes. कोई class नहीं होगी, कोई training नहीं होगी, कोई modification नहीं होगा. तब खत्म. अब बस एक क्वेश्चन पेपर बनेगा और जीवन मरण के सवाल वहीं पे जो आया आया, नहीं आया नहीं आया. ठीक है. That is testing. अब वो वहां सवाल नहीं आएगा तो that tells what is your CGPA, what is my model accuracy, अब वो report होगा. Now we will not get back to training. So to stop that, एकदम exclusive करने के बजाय we apply validation so that we could keep on changing. Or this is the curve that should tell you. Let me take one parameter only. Talk about accuracy. If accuracy is there, the training accuracy increases like this, and validation accuracy increases like this. There will be a time when there will be a big gap in between training accuracy and validation accuracy. ट्रेनिंग को बहुत अच्छा लग रहा है कि नहीं सब समझ रहे हैं, लेकिन जब क्वेश्चन पूछना शुरू किया तो समझ में आ रहा नहीं किसी को पता नहीं क्या हो रहा है. That is the curve that shows कि model is. So I'll skip these. These are just fundamentals. I'll start from here. This is a neural network, and since we have started calling it a network, of course there should be some things which are combined together to create a network. We have an original input, we feed it through layers, and at the end we try to predict something, right? It doesn't happen like this in theory, in the mathematical detail, but this is how something we visualize it. In deep learning, it happens like we have an image. That image is taken through layers, then some representation is achieved. Those representations are being learned by the neurons which are in. Then from one representation to another representation, then to another representation, and finally we land up with one possible value, and that value should indicate what I'm trying to predict. Okay? This is a multi-class classification problem in which I feed an image of a handwritten digit, and I try to predict what that digit is. Okay, very simple example. Now this is how it happens in origin. If you look at it, you would observe that the image is fed to 784 numeric values, and this is an input layer. But although it is called input layer, but it's not certainly a layer. Nothing happens over here apart from just taking the data, accepting the data. No computation happens over here. Computation happens in hidden layers and the output. Hidden layer means between input and output. Previously, the neural network was supposed to be a black box. So what we were exposed to was input layer and output layer. So anything between them was termed as hidden. The hidden layers. Now within hidden layer, you would observe if it is 7, some of the neurons are lighting up, some of them are not. And then finally, I need 7. If it probably I had another chip which had multiple digits. But even here, you observe that not all are lighting up. These are still not doing it. They are not activated. Only few are. And it happens all the time. Why it happens all the time? Probably they are waiting for some other pattern, some other region of the network to be illuminated. Some other region of the image to be activated. Suppose I have this image and it is 7. 7 is looking like this. So this portion is blackened out, this portion is blackened out. Suppose I have 8 and 8 might look like this. Okay? So there are some neurons which are waiting for probably this portion of the image to be blackened out so that it will activate. Because that neuron is actually looking for this portion of image. And since this portion of image is not activated, so that neuron will not get activated. It is like this. This portion is blackened. This portion is not blackened. And the image is like this. So there are other neurons which structure looking for other regions of this image to be blackened out so that they may activate. And if it is not activating, it means that portion is not blackened. Okay, it means there is nothing like that. So if that portion is not blackened, these are not activated. Which are activated, combined together to create another set of activated neuron in next hidden layer, then next hidden layer, then next hidden layer, and finally all of them combine their knowledge together to make one neuron activated in the output. Okay, only one neuron will be activated through a combined effort of these many, so that this neuron will finally tell me what was the image that I'm looking. Keep trained one, okay. But how do we get start to करेंगे scratch? ठीक है, या लिटरेचर स्टार्ट करेंगे. तो एक बेसिक मॉडल से यहाँ तक हम कैसे पहुंचते हैं? आफ्टर ट्रेनिंग. Alright, we have to train the model, and after training, I expect this kind of result. जो इमेज दिया, तो corresponding neuron activate हो जाए, and I get the answer. Neuron is activated, it will give me some value near to 1, and remaining will be. It is still numeric value. I'm only getting numeric. ठीक है? So this is the kind of expectation I have. I must create it from a single neuron. This is a single neuron. A neuron is a composite function. Again, I'm talking about function. Neuron is a composite function. As I said, there are many neurons, hundreds of thousands of neurons here, and they are nothing but this composite. WX plus B. I expand W and X. Okay, so it is a sum of all the features with weight associated. So I can call it a weighted sum of all the features. So I can write it like this. Summation of I equal to 1 to D Wi xi plus b. Okay. You can also write it like this. So the difference between this and this is just I was starting from 1, now I is starting from D. Why? Because this B I have taken into like this. W0 is 0. So I have taken that expression and simple trick. So summation of values from 0 to D, and that is what is happening. And in this what is happening? What is x0? W0 plus x0 was B, the pi. So if I say that x0 is all the time 1, then I just need to know W. कितना वेटेज होगा बायस का. अगर बायस बहुत वेटेज है, इसका मतलब अननोन बहुत ज्यादा है. अगर बायस का वेटेज कम है, इसका मतलब अननोन कम है. I have to find a balance. So x0 is 1, and that is represented. This one value is what is representing bias. ठीक है. और इससे जो ये W4 जा रहा है, that will be my WC. Right? Okay. Now I have this mathematics and this kind of I'm just taking a simple value of 1. Right? Assuming, because I can very simply assume see what is B. B I can call as B dot 1. Okay. So I am saying X naught is 1 and W naught is 1. It is always constant 1. Because all x's are variable. Now every. So what will happen? As you said, we calculate bias, right? Calculating bias. So what is the value of bias? Right. So as you said, I have already written the value of bias. What is the value of bias? Input x0 and w0 combined, right? And that is what I'm saying. X is 1. Always. Right. So 1 multiplied by w0. Right. That w0. So what is w0? That is the one. You will calculate, right? I didn't put any value. I'm just playing. I'm saying you agree to, I need to calculate B. Have I given it any value? As per you, I have given it a value of 1, right? But you feel that it should be calculated. I should not put a very strict value to it. I should not put any value to it, right? I agree. I'm doing the thing. How? I'm saying this is B. At this point of time, I'm only putting a value B. I'm not doing it anymore. Then I'm calling it W naught X naught, and you say I gave a value of 1 to X naught. Okay? But say X naught is B. Because I have to put it in the summation. I have to bring this in only summation. And now, so B was there. I said B dot 1. And in parallel to that, I said W naught dot 1. And then this one I remove very slowly and then put X naught. And say this will be always 1. But then B is equal to 1. X naught is always 1. Okay? So 1 into anything will be anything. And this I need to calculate. If I need to calculate this, I need to find out this. It means I need to find out bias. Here also I am calculating that. I'm not putting any value. I'm just multiplying it with 1 to bring it over. और ये 1 कहाँ से आ रहा है? हर बार में 1 लगा रहा है. This 1 is not bias. Understand? This 1 is not bias. This is. Okay? And since I'm calculating the value of W4, so I'm also calculating. So just we are playing with representation value, variable name. All right. You understood X naught to be biased, but X naught is not biased. W naught and W naught I'm calculating. That is a parameter. Yes. No, you know. All these things I need to calculate. I need to enable. These are parameters. All are. We randomly start from any random value. What's your name? Okay. So again, listen. We start from random values. Okay. In ML also, when we calculate bias, we start from a random value, and then we tune it so that we come up to a final optimized value of bias. Here also, I will start with a random value. W4 will be a random, but W4 where is it coming from? It is coming as a bias. So W1 is associated with the known X1, the weightage of X1. W2 is associated with the known X2, the weightage of X2. W3 is associated with known X3, the weightage of X3. W4 is also associated with the known 1. It is not input. It is just accompanying the bias. And this is the bias that I need to calculate. All W1, W2, W3, W4, we need to find out, calculate. These are called learnable parameters, and we will be learning them. So all these x's are known. All these x value are known because these are the input values. And b was unknown. So I divided b as b dot 1 again. Just simple trick. Nothing more. There was just b. There was just b. Then I said b is not b alone, b is b dot 1. Okay. Then I said let us not call bias by b, let us call bias as w naught. And still this 1 is there. So instead of bias being represented by alphabet by an alphabet b, I started representing with w naught. ठीक है? And I need to calculate this. और इसको करने से क्या हुआ? इसको I could represent it at w naught x naught, or x naught will always have a value of 1, that is represented by this constant input. ठीक है? By constant input. But this w naught will be the bias that I need to calculate. और इसको करने से फायदा क्या हुआ? I can represent it in a substance form. And this part, if I can represent it like this part is actually this neuron up to here. Up to here is that mathematical function. ठीक है? Any question? Right? So this up to this part is nothing but a weighted sum of all input values. This is a neuron. I am now creating a neuron. So it is a composite function. You give it some input and it gives you some output. Nothing more than that. Composite function means at this point I have just calculated the weighted sum. This weighted sum will be represented by standard alphabet Z or Z, and we call it legit. Legit. We call it legit. This is actually there is very precise explanation, very precise mathematics of why is it called legit, but it has a long background. So I'll not explain why is it called legit, but this weighted sum up to this point is called represented by Z. Okay. Now, since machine learning is already completed in past 4 days, we are into deep factors of very complex algorithm. They are not linear. They are non-linear. Okay. Linearity has its limitation. So we will not be limited to linear function. This is the linear. I need to introduce non. So to this linear function, I will introduce non-linearity not by the step function but by the logistic function. Logistic regression parameter. So instead of having a neuron, simple linear regression up to this point is linear regression. यहाँ तक linear regression चल रहा है. This is the actual expression. But linearity has its limitation. Linearity has its own power, limited power. So I'm not going to restrict my algorithm by linearity. I'm going to introduce non-linearity by putting this legit into a function called sigmoid function. I'll feed this z into a sigmoid function which has an expression of 1 upon 1 plus e to the power minus. Okay, this is a sigmoid function. S function. Right. जब आप थक जाएं तो बता दीजिएगा, because I have a 3-hour span and I am habitual of taking 3-4 hours classes on a stretch. So it's your willingness, how long you can endure me, right? So 1 upon 1 plus e to the power minus z is the sigmoid function, and I take this expression then and I feed it to this sigmoid function. Now this whole I have reached over here. This is a step function. This is a historical. Actually, this whole slide was created to teach a class. So I'll skip this part why this step function was created. It is not differentiable. There is a bend over here. So I want a properly differentiable function. So this is a properly differentiable function 1 upon 1 plus 2 power minus z. So instead of step function, I will use sigmoid function. Sigmoid function has a term like this. It reaches 1 and the input is very high and reaches 0. It ranges from 0 to 1 S function like S. Just like this, but a smooth curve. So sigmoid function has a maximum value of 1 and a smallest value of 0. It ranges from 0 to 1. So when I take this legit, I will feed it to a non-linear function, that's sigmoid function, and the output of that will range from 0 to 1, and that will be the output of our neuron. Single. Okay. Now, consider the perceptron with this. Okay, forget about the step function because we are getting into perceptron to, yeah, this is the curve of sigmoid function 1 upon 1 plus e to the power minus z. It ranges from 0, so y value will be 0 to 1. And when the weighted thumb closes to infinity, positive infinity, the sigmoid function, if z reaches positive infinity, the sigmoid function reaches 1. When the z reaches negative infinity, means the value is very low, it reaches 0 to 0. Okay. So this is the whole neuron. I have set of input values along with bias also. Now I will not discuss bias separately. Okay na? I assume that bias is x equal to 1. हमेशा उसको input को 1 कर दिया. And I need to learn W0. तो W0 ही bias रहेगा. ठीक है? तो ये W0 से लेकर WD तक. Why am I taking D all the time? N क्यों नहीं, M क्यों नहीं, X क्यों नहीं, J क्यों नहीं, D क्या है? Is dimension. So I think all of you understand what is the meaning of dimension. That's the number of features of the observation, right? And this dimension represents how big, how many dimensions there are in. So from 0th dimension to the 0 dimension, so W0 is actually mathematically taking care of the bias value, and W0 to WD, starting W1 to WD is the weightage of input value. और यहाँ पे input value कुछ है नहीं, so W0 is biased and it is taken care in one succinct. And this is the legit value Z that I am getting is K equal to 0 to T WJ is K. और इसको sigmoid function में लगाए, sigmoid function लगाने के बाद क्या है हमारा final output of that of a single neuron. ये हमारे neuron का value आता है. अब ये एक neuron का value. What will the output numerically? 0 to 1, 0 to 1, 0 to 1. सारे neuron. ठीक है? Now between 0 to 1, we say the neuron has activated if the value goes beyond 0.5, और अगर 0.5 के नीचे है, we say the neuron has not activated. Okay. Okay. So now till this point we have understood neuron. Okay. Now we need to understand the network of, and this is the network. We start with input layer, which has got how many neurons? 0. Because neuron input सिर्फ input लेता है. अगर हमें previously हम representation की बात करें, this is input layer. You see all of them will be illuminated. सारे illuminate होंगे. Okay. सारे से value आ रही है, सारे deactivated. But all of them are just accepting values. They are not neuron, because neuron means those computations. अगर वो computation नहीं हो रहा, they are not neurons. So they are not neuron, they are just accepting values. So input layer, we say input layer, but normally input layer is nothing. जब आप CNV calculate कर रहे होंगे, at that time you would have started with conv 2D. First layer would be conv 2D, है ना? Was there any input layer? No. In conv 2D, first conv 2D, you just specified what would be the pattern of input. कैसा आएगा? ये किया था ना उसमें, कितने न्यूरॉन आएंगे? That's it. So we start from here. Conv 2D ये है, conv 2D ये है. This is not conv 2D. This is just how input is being given to us. All right. So input does not have any neuron. Neurons start from hidden layer. So this is input layer. It just provides the input. Neurons are here. 1, 2, 4 neurons are there in this network. So x0 probably x1, x2, x3. These 4 values are coming. What will be x0? X0 will always be 1. X1 will have some value, x2 will have some value. There are weight value. Weight values are on edges. All these edges will have some weight. And what I will do, I will take this input, multiply with the weight, and then give it to this neuron. I will take this input, multiply with the weight associated with this edge, and give it to it. I'll take the input value, multiply the weight associated with this edge, and give it to the neuron. Finally, I'll take the input of this neuron, multiply with the weight associated with this edge, and give it to this neuron. What this neuron will do? Take all these 4 weighted values, add them, then give it to sigmoid function and produce a value. And that value will come over here. Then again, the output of this neuron will be input to this. There will be a weight associated over here. This output will be multiplied with the weight associated over here, given to this neuron, and similarly, two more weighted values will get over here. It will do the weighted sum, pass it on to sigmoid function or any other function, and then give it. That is how network functions. Any doubt? Okay. There are hidden layers, there are output layers. Now, how does it learn? यही होता है. Okay. So, input is given from here. It propagates in this direction. We call it feed forward method, where I'm just feeding the input, and through a series of those calculations, the value is being forward direction for us, and at the output layer, some output will be generated. Now let me erase all of it. I'm not getting too mathematical, and so that I'm actually making this leap, right? Because I will get more mathematical from here on. So what is happening is I fed the input to this black box. I generated an output, right? So input was x, and output is fx, because this is function f, and this is function f that I'm trying to create, right? So I fed x to f, and output is. I will compare. I will compare fx with y and ask this question: is it equal? So of course, it may be seen different, right? How would I come to know if they are same? I will perform their. I'll find out their difference. F x minus y. Y of x minus y. First, to calculate difference between two entities, the simplest I know is subtraction. Subtract करके देख लेते हैं अगर zero आता है तो equal है. But there are more. I don't know very much mathematics, so what I did, I just subtract. And there are people who know more mathematics, so they might apply more complex formula. Okay? But this is the mathematical kind. So I just take their difference, and if it is zero, I'll say yes, they are equal. Otherwise, I'll say no, they are not equal. But it is possible that it may be negative, it may be zero, it may be positive. Okay. So what do I do? All of it will become zero, or positive. They're positive or all right. If it is positive, then fine. If it is zero, that is what I want to achieve. Okay. So, and since I have taken a square of it, what kind of curve it will represent? Parabolic. Parabolic y curve. to x square is the parabolic curve, right? So it will give me a kind of this curve, parabolic curve, which will have a minimum, also have a maximum, but the sign reverse करेंगे it will be. I'm trying to look for minimum. Will minima always be 0? Not possible. No, okay. It's not possible to get fx minus y equal to 0 because b unknown was always there. If it is unknown, I will not get 0. There will be some error will be there. 10 to the power minus 9 error may be there, but error will be there. So it will not be 0, but it can be minimum. Okay, and that is my target. What I want is to generate fx such that fx minus y is equal to 0. To get fx minus y 0, what I did, I subtracted them. I was not happy with the negative sign, so what I did, I took a square that make it positive, and I got, coincidentally, I got a parabolic curve, and parabolic curve has got a minimum. I will try to factor. All right. So what happened? People started. There are standard algorithms with which you can find the minima of a function, and that is a very well known. There are others also, but a very well known one which is called a gradient descent. So what I'll do, I will take, if I had known calculus, if you remember your calculus, you would know if you see the curve, if I have to find the minima or maxima, I differentiate it once, equate it to 0, differentiate twice, if that comes out negative, minimum or maximum. Okay. To find out the inflection point, I can differentiate this curve and get the inflection point, minimum or maximum, easily. But do I know this? Because fx minus y square not known to me because f is not function. क्यों नहीं पता ये फंक्शन है क्या? हमने तो यहाँ से शुरू किया था ना, w to x 0 plus या इसको properly if I have to do that, this is basically 1 upon 1 plus e to the power minus summation wi x, right? सही है ना? ठीक है, यही फंक्शन है ना? इस फंक्शन में सब कुछ पता है हमें? Do we know everything in this function? What is unknown? W values. W values are, we are just guessing W value. अभी तक हमें W पता नहीं, हर जगह हमने W रखा है, but we do not know W. We started with a random W, and we need to find the concrete value of W. So we do not know. ये parameter नहीं पता, function नहीं पता, so we do not know this function. अगर ये function नहीं पता, तो हम इसको differentiate कैसे करेंगे? So we cannot apply simple differentiation to find out the inflection. What do we do? We find out the gradient. We find out the gradient of error at any point of time. We differentiate it with random value, जो भी random value, and we find out the gradient. So what gradient is? जो भी curve होगा, whatever this curve would be, at given value of w, जो भी parameter होगा, according to that, gradient is nothing but a multivariable differential, right? So differentiation is single variable dx by dy, dy by dx, and this is dy del y by del x1, del y by del x2, del y by del x3, up to multiple variables are there. So this is partial differentiation with respect to a given variable. This gradient is nothing but multivariable. It will give me a tangent at a given x1, and this tangent is very unique. It points in the direction of maximum ascent. All right. So if I have to find out this gradient, what I'll do? Suppose this is, let me call it R. Let's not call it R. Let me call it L. L means loss. Okay. How much is the loss? So what will happen? I will perform a gradient on it, and gradient will be del L upon del W. This is I against, we will differentiate, partial differentiate. So what will happen? Del L upon del W will give you this tangent, tangent will always point in the direction of maximum ascent particular point. But हमें ऊपर तो जाना नहीं है, हमें तो तरफ जाना है. So what I'll do? I will multiply it with the negative sign. Sign change कर. This एक vector का sign change कर दी. क्या होगा negative sign? Change कर point करने. Right? I just change the sign of that vector. So its direction is reversed. Now it is pointing in the direction of maximum descent. Right? So it's gradient and it's descent. But when you descend, क्या करना है? I'm trying to find out this position. And this is just the curve of error. This curve, parabolic curve, is the curve of this error function. ये हमारे function का fx का curve नहीं है, error curve, right? Error curve parabolic. If it is parabolic, I need to find this minimum and I need to reach this. तो यहाँ से शुरू करेंगे और हम एक कितना बड़ा करेंगे, कितना बड़ा gradient का magnitude है. This vector del L by del W is the vector. With the sign, I understood which direction I need to move, and with the magnitude, I will know how big a step I need to take. ठीक है? But यही हुआ. So suppose this is the magnitude of the vector. I reach here. Then I took another step. I reach here. Right? Did I reach minimum? So what I'll do? I will have to come back. फिर यहाँ पर है और फिर यहाँ पर. Did I reach minimum? What do I do now? Step size. I need to reduce, but that is the gradient of this function. Scale. So I need a scaling parameter alpha, that is also called a learning rate, to scale. Alpha will be between 0 to 1, right? If alpha goes down, this step size. I can reduce it so that I see. So if the error is large, suppose this is error. If the error is large, the step size is big. I need to move this location far. So alpha will be large, 2, 3, 4, 5, 10, whatever. And if I reach closer to smaller error, alpha will gradually reduce. This will 0 to 1 mil. So whatever with the step size will gradually. Ultimately, I need to towards last iteration, I should be at the minimum, very close to minimum, as close as possible. Okay. So this is called gradient term. This is called gradient term. This gradient term is added to the existing value of parameter. Now let me take clip of some slides and with those slides. Okay. So this error, the R or L or risk or loss or error, whatever you call it, this curve is a function of beta, the value, the parameter or W. Okay, the beta is parameter W. So whatever be the value of beta on x-axis, according to that, the error will be calculated. I need to find out that value of beta or the parameter W, which will give me minimum value of n. Okay? So what happens if I start with a random beta value or random W value? Let's say this is my random W. Let's say I'm here. Okay, so here. So this is the beta value that I started. So this is the beta value I started because I started with a random W. So I need to move in this direction. Okay. So my original beta will be called, original beta is called beta code. Okay. I need to move in this direction. So this original beta will be added with the gradient term. Will be added or modified with the gradient term such that I move over here towards a smaller beta. And this will be gradient term is what? Minus alpha del L upon del W is the gradient term. I will add that old beta and I will get new beta. I'll get new beta. So new beta will be, instead of here old beta, new beta will be somewhere closer to the optimum. This is the beta optimum that I want to achieve. Suppose my random beta started from here, then what will happen? The gradient will take me to this direction. I will reverse that direction to lower, to descent, and then from there also I will move in this direction. तो अगर random beta यहाँ से start करें, चाहे यहाँ से start करें, वो move करके आएगा इसी optimum की तरफ. Because gradient tells you the direction in which you have to achieve value. There is a problem with gradient descent. ये local minimum ही लेता है. ठीक है, global minimum नहीं ले जाता, but that is not the structure. So this gradient will take you towards beta optimum. Okay. So this is with which these neurons are trained. Beta dash, the next position, new position. Beta is the current position, negative sign. The minus sign refers to the minimization part of the gradient descent. Alpha is the step size or learning rate, and del R beta upon del beta is the gradient term, is the direction of the steepest ascent. So new beta, new parameter is equal to old parameter minus alpha del R upon del beta. This is the gradient equation. What is gradient term? Starting from negative side, this part is the gradient. ठीक है. अब ये क्या करता है? ये हमेशा हमें लोअर एरर की तरफ ले जाएगा, हमेशा, डेफिनेटली, गारंटी. अनफॉर्चुनेटली लोकल मिनिमम में रखता है, लेकिन ओके. तो व्हाट वी डू फॉर मिनिमाइजेशन, हम एरर में अब न्यूरल नेटवर्क ट्रेन कैसे करेंगे? हम क्या करेंगे? सारे बीटा पैरामीटर, हमारे पास कितने पैरामीटर थे वहां पे? W0, W1, W2, WD, D+1 पैरामीटर थे. तो विद रिस्पेक्ट टू एवरी पैरामीटर हम एरर फंक्शन को डिफरेंशिएट करेंगे, विल टेक ग्रेडियंट, और हर पैरामीटर के अगेंस्ट ये अपडेशन कर. सो इट इज ओनली टॉकिंग अबाउट टू बीटा वैल्यू, 0 और 1. ठीक है, अगर सिंगल डायमेंशनल वैल्यू है तो उसका बीटा नॉट प्लस बीटा 1x1 होगा, यही होगा. तो यहाँ पे हम टू वैल्यूज की बात करें, दो पैरामीटर. अगर आपके पास D+1 पैरामीटर है तो ये D+1 टाइम्स बीटा वैल्यूज मॉडिफाई. तो इतने पैरामीटर एक साथ साइमल्टेनियसली ऑल बीटा वैल्यू. इससे क्या होगा? एक स्टेप हम आगे बढ़ेंगे इधर टुवर्ड्स लोअर. ओके, वन स्टेप एट अ टाइम. So you understand the complexity of neural network. We are creating hundreds of thousands of neurons, and for every neuron, while training, we are taking a very small step towards lower error, one parameter at a time, when there are millions of them. Okay, that is the neural network, the deep learning model required resource. So there are number of calculations. So how many neurons we normally have? It normally goes into hundreds of thousands of neurons. Okay, each neuron has to perform the linear regression in feed forward. So feed forward is very easy. It is just freezes back propagate. We calculate the error and we need to back propagate the gradient of that. So first we need to calculate the error, then we need to calculate the gradient with respect to every parameter. How many parameters are there? Even in a single line, there are hundreds of thousands of parameters, or let's say thousands of parameters. So for thousands of parameters, we need to update this error function one parameter at a time. ठीक है? और ये काम हम कितना करेंगे? सारी लेयर में. This will happen in all the layers. So this is forward, read the input, calculate legit, calculate sigmoid function, and come to this part. This part I have evaluated fx, fx को y से compare किया, loss function calculate किया, loss function का gradient लिया, gradient is respect to all these beta values, और फिर उस gradient term को पीछे ले गए और जो भी weight values थी उनको modify कर दिया, right? तो और फिर इसको इन weight values को modify किया, फिर यहाँ से यहाँ आए, इन weight values को modify किया, और ये weight values फिर adjusted weight value की जाती है. So that is one iteration, and this one iteration of, so when I come in this direction, this is called feed forward. When I go back, it is called back propagation. And when I back propagate, that is the part where neurons are changing themselves, they are learning. When weight values are changing, the neural network is said to learn. वो learn कर रहा है. क्यों learn कर, अच्छा ही learn कर, क्यों कैसे कर रहा है? How do we know कि it is learning in the right direction? Courtesy to gradient descent, because gradient descent is definitely guaranteeing that it will take the neural network in the direction of lower error, right? If the error is minimizing, I can guarantee myself that okay, network is in the right direction, and that is guaranteed by gradient descent. That is the simplest algorithm which comes to help us, and it guarantees that error is going towards smaller value. And it happens again and again and again. So suppose you have 50,000 samples. So every time you feed one sample, calculate one error, perform the gradient descent for that error. करेंगे तो 50,000 feed forward and 50,000 back propagation होगा, right? But this is very costly. Okay? This is very costly in terms of computational efficiency. And we all understand that there are two parts with feed forward and back propagation. Feed forward is easy, very small computation, but back propagation is heavy computation intensive task. So what we do, we don't do it for one sample at a time. हम क्या करते हैं, एक batch, right? We create a batch. How big a batch you would want? Again, I have 10 का, 20 का, 100 का. Normally 100 बहुत बड़ा amount है. 20 is normally seen. Let me call it J. 20 samples का एक batch बना लिया. 20 samples का batch बना लिया. उनके errors feed forward 20 times feed forward कर दिया. फिर उसका एक सम ले लिया, सबका एरर का सम लेते गए 20 टाइम सम करते गए, और उसका एक एवरेज निकाल लिया, राइट? 1/4 एक एवरेज. नाउ दिस एवरेज का अब बैक प्रोपगेशन, तो 20 टाइम्स फीड फॉरवर्ड एंड 1 टाइम्स बैक प्रोपगेशन. बैक प्रोपगेशन वाज हेवी ऑन कंप्यूटेशन, कम कर दिया, और फीड फॉरवर्ड तो कर रही है, इसको तो अवॉइड कर नहीं सकते. तो 20 feed forward, 1 back. और इससे are we losing something? No, because जो ये back propagation हो रहा है, this back propagation introduces such a small step. तो gradient descent होता है ना, we take a step ahead towards minimum value. So that step is so small. This step of moving towards minimum value is so small कि अगर आप 20 का बैच ले लें तो भी कोई बहुत बड़ा फर्क नहीं पड़ेगा. इट विल इन द राइट डायरेक्शन एंड कंप्यूटेशन विल रिड्यूस. ओके, एंड दिस काइंड ऑफ back propagation in which we are combining the errors of a certain set of values is called batch gradient descent. Okay, this is called batch gradient descent. And if we do it one sample at a time, that is called stochastic gradient descent. ठीक है? Ideally, batch means the whole lot of training samples are fed. तो अगर हमारे पास 50,000 sample है, तो we do 50,000 feed forward or single back. That is batch. लेकिन that is too big. 50,000 का वेट नहीं कर सकते, है ना? हमें इसको understand करना है ना how good the training is. तो batch is whole batch of samples. तो हम क्या करते हैं, midway is called mini batch training. But mini batch बहुत फैशन में नहीं है. So there are two extremities: stochastic gradient descent and batch gradient descent. Stochastic में क्या करते हैं? One feed forward, one backward. ठीक? That is too complexity, too much computation intensity. The other is too simple. 50,000 feed forward किया और एक back propagation. So no, that is losing. Let us fall somewhere in between. 20 samples का feed forward और एक back. 20 samples का feed forward और एक back. But mini batch करना. But mini batch और batch को alternatively use करते हैं. और mini batch बोलना बहुत बड़ा हो जाता है तो we normally call it batch. Okay. All right. I'll not get into the detail of the derivation that I have over here. Okay. So I have this slide which says, which through this slide, I'm actually trying to derive it. Sure, definitely. Just I'm going to break over here. So I'm just telling what I'm not going to tell. So I have this slide which says there are two types of neuron. One is output neuron and hidden neuron. Okay. तो आउटपुट के लिए कैसे बैक प्रोपगेशन एक्सप्रेशन क्रिएट होगा थ्रू ग्रेडिएंटेशन और हिडन के लिए कैसे एक्सप्रेशन क्रिएट होगा I'll pass these slides so you can read on your own. These are simple calculation. So once you go through, these are very elaborate. You'll understand how this expression comes up. Okay, but ultimately it will boil down to a simple expression, and that expression we need to remember. What is happening? Right. So this is the whole back propagation algorithm. Feed forward bana liya. Initialize odd weight value with random and repeat. For each training example, here we are taking each, not the batch. Feed forward, propagate example X through the network and compute the output value for every neuron. Back propagation happens, propagate the error or gradient of error. For each output neuron K, calculate its error like this. So this is the output value for kth neuron, 1 minus output into y, the expected output minus obtained output. Okay, the actual output that is the number. So we know what value is generated. Y is something that we are expecting, that is given to us, and this expression is created in terms of only known values. Okay? So if it is an output neuron, this is the gradient of error that we pass back, and if it is the hidden neuron, this is the gradient of error that we pass back, and this updates again and again and again, as long as our error is not within our acceptable range. Okay, this is how neural network trains. Let's take a break, and we'll come back to it later. Any question? Okay, after you energize and Huh?
Yeah, I guess what?
Huh. All right. So I will stop here about the basic neural network and I'll go to CNN. Okay. There are a lot many things that we may need to understand, but I don't think this will be the proper platform to learn like a class. But there are a lot many things. Not neural network does not have only feed forward kind of application. The application is also very important. How we apply, where we apply. Okay. And any, as I said, as I gave the example of hammer, you have to tune that hammer so that it could be applied to your application domain, your problem area. Similarly, in CNN, we have modified the neural network in such a way that it is applied to image processing task. CNN is very specific to image processing task only because it tries to find out a pattern in the input at a given location. Okay. It is somehow related to location, but not bound to location. There are other type of network like unit is there, cycle GAN is there, which is specifically bound to a location, but apart from that, I'll not discuss that. CNN is something that tries to find a pattern in a given location in the input or a particular region specific. So, and for that matter, all machine learning algorithms try to find the pattern. And the function f that all the time we are trying to find out this function, whatever function comes out, whatever be the graph of that function, that is the pattern of the input, right? The solution. So once you identify pattern, it means you have identified this function, and this function is the model. And if the model is there, all the input x will provide value close to my expectation. Again, as soon as you understand the pattern, you have understood the model you have created. CNN also tries to understand the pattern. What is the pattern? And more visibly, instead of just talking of the pattern mathematically, this tries to find out the pattern visibly. I will be able to visualize how this pattern is actually being found out. As I give the example of a right? If I ask you to find the face, or forget about face, I ask you who is this person, you will immediately tell me Barack Obama. As a human, I don't need to tell the human computer where to look at. Okay? You identified this person by looking at his picture. What is his picture? What does it mean by his picture? Does it mean this portion? What is this portion? This portion is, what is this portion? Huh? What is this portion of the image? It's body. But are we seeing his body? It's just a portion which has something black, gray, black, something. It's only colors which is there, right? If I feed this image, it's all values, numerical values, RGB, right? R channel, G channel, B channel, red color, green color, blue color, that's all. And different intensity values ranging from 0 to 255. That's it for R, green and blue. So what is actually fed to computer is the different intensity values, and that corresponds to blackish gray color, white color, and probably tie is definitely total gray. How did I recognize it to be body, it to be his jacket, it to be his blazer, it to be his coat, tie, shirt, whatever? And then again, the question is not even that. The question was, how did you recognize this person to be Barack Obama? First of all, is there a person over here who told us? Then if there is a person, where is the face of the person? What does it mean by face of the person? If it is a face, how does it match to the face of Barack Obama? There are so many questions that are immediately answered without even thinking by a human computer who knows what to look, where to look, right? And how to answer. So as I showed this image to you, immediately you would have, first instant you would have looked at his face. Did you look at the Capitol Hill building in the background? No. That would be secondary. Did you look at his suit? No, again, that would be secondary. His tie, probably tertiary. Capitol Hill, okay, if somebody asks, "Arey, Capitol Hill hai kya?" Okay, something like that. So we know where our attention should be, and that attention actually has generated another set of attention networks. GANs are there, right? There are different bird technologies are there, attention networks, transformers are coming up. So our attention immediately went to his face. So I know what face is, what face looks like. So if I tell you, this is the face which is bounded by this green rectangle. What is there should be called a face, or what constitutes a face? If I say this is face, so and I ask you question, what constitutes a face of a person, human being? Nose, eyes, lips, eyebrows, forehead, cheeks, teeth, lips, right? All these things. But while looking at that face, did you actually try to find out his nose? Did you actually try to find out his eyes, eyebrows, teeth, lips, ears? क्या ढूंढा इसमें? You found that okay, this is a face. What did you actually look at to call it a face? What unique feature, if I talk in terms of machine learning, right? In machine learning, we divide our data, we divide our observations into features, x1, x2, x3, blah, 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 right? So this is the data, this image is the data, fine. And I need to divide it into set of feature values, x1, x2, x3. So if I ask you to find out face, you found out, suppose this bounding box is a face. But then in face, what are x1, x2, x3s? Kya those individual features that you found out as a human being, human computer, which combining together you called a face. What was the unique feature in this face? What was unique in this face? What did you find out? Okay, same question again. So when I asked you, who is this person? Did you categorically first find out the face, and then in his face you found the nose and compared it with the nose of Barack Obama, that you remember? Or you found out the eyes, compared with how many eyes Barack Obama has, or compared with the lip and number of teeth he has? Whatever, that is my question. What is that pattern? How do I write that pattern in terms of x1, x2, x? How do I differentiate those features? How do I write those? So I have to define nose. Let me define nose. Okay, please. How do I define nose to be x1, x2? What value? Numerical. It all has to be numerical. So how do I define my x value? There is one position. Position related to what? Relative to this value or this value? The origin of this image. Will it always be same? Or suppose this position changes, then Barack Obama will become Joe Biden? Then, and if it is nose, how do I measure nose? Is it this length or this width or this width? What is it? Or the width between it or this whole cone? There an end to it. Even if I start describing his nose, will there be an end to what his nose actually is? At this point, he's smiling, so probably he might have a crooked this stretch, right? If he's not smiling, he's very angry and his nose will be like swollen nose. Will he not be Barack Obama at this point of time? Because I'll be overly describing, overputting his nose as nose of Barack Obama, right? Does it happen like that? And even if suppose it happens like that, did you, while recognizing Barack Obama, actually measured his nose and compared to the measurement of his nose? Everything, right? I find that very agreeable. Everything is fine, but everything is not written as the in terms of features. Features we need to define. How do I define features for those agreed? Primary or secondary, it all has to come down to x1, x0, x1, x2, x3 of x. How do I write those of a face? Can you define texture? I can define shape, I can define color, texture, shape also. What is shape? What is his face cutting shape? How do I define it? That's what I said about you, right? We cannot. That is something that was being done by previous paper, the Viola Jones paper. Viola Jones paper. This is what is happening. Here they were trying to match and identify the features of a face. But again, while you looked at this image, did you try to segregate this face into this filter, then this filter? यहाँ के बीच में nose होना चाहिए, there should be a pair of eyes. ऐसा कुछ किया था identify करते हैं? नहीं. As soon as your brain saw this image, without any measurement, without anything, you looked at the whole, everything, right? And you identified that everything to be his face. Now, how do I represent that everything as a feature, set of features? I cannot. Okay. So if I cannot, the machine learning model will not be able to give me the answer, because that wants me, the machine learning wants me to define all input in terms of feature vector. And I will not be able to define a face in terms of feature. Viola Jones tried to do this, but they were successful relative to whatever their data set was. Out of 507 cases on a data set of 130 images, 507 cases, the algorithm achieved an accuracy of 91.4%. Very good accuracy. But as soon as we change the database, the accuracy dropped down. Or it doesn't happen like that. Okay. If we are imitating a natural process, nature or human brain doesn't recognize a face like a measurement. It just finds out the pattern as a whole. So if I'm not able to find out the features, machine learning will fail here. That is why the face recognition was a failure in terms of machine learning. Machine learning was not able to find out faces. Then what do? We don't find features at all. We just feed the input. जैसे आ रहा है वैसे feed कर दें. This image, this was an image in terms of pixel. From here to here, there are certain number of pixels with certain intensity value. Red, green, blue. 3 channels or 1 channel, just grayscale 0 to 255 values. I've got these values. I feed it to the model, and model should learn what to learn and how to learn. To damn with the process. Let the model do it. Okay. When I teach a kid how to recognize a photo, did I ever tell how to do that? एक फोटो ही तो दिखाई थी, सिर्फ एक इनपुट दिया था, और वो बच्चा कैसे, how does that kid learn? Why do I care? Let the brain learn, let the nature take care of it. The same we are going to do over here. But ऐसे कह देने से तो होगा नहीं, right? We have to have some algorithm. So all those problems where we will not be able to define the feature of my input, deep learning comes, and machine learning will definitely fail. Right? If we are not able to define particular feature, how this input is segregated into set of feature values, machine learning will fail. And then there comes the deep learning. The deep learning is just looking for pattern. without specifying what a pattern should be. Okay. So, right. So what happens? We feed an input. In this case, image is an input. The image is actually, it should be in reverse order. The input starts from here, right? And then it goes back. So there are some patterns like nose, lips, eyes, left eye, right eye. I don't know what this is. This is for head, and this is probably chin, right? So chin, head, and then it's further segregated to the more segregation, more abstraction, and then finally zeros and ones converted to zeros and ones. How it has to devise this model, neural network has to devise its own method of doing how. Okay. So from here, the input is segregated to learn important pattern and discard the unimportant. Gradually, it come out to identify, okay, all these things constitute together to define George Washington. And those useless things will be discarded. Forget about regular connected. This is convolutional neural network. Convolution involves a process of multiplication of two matrices. Okay, we have two matrices, that is a big matrix and a small matrix. I take two matrices, and then what I do, I take this small matrix and convolve over the big matrix. What does it mean by convolving over big matrix? Okay. So there is a big matrix and there is a small matrix. I take the small matrix and convolve over the big matrix. Now, what does it mean by convolving over the big matrix? Convolution just involves this thing, element by element multiplication. Basically, it is a dot product. Okay? So I have two matrices. They should be of the same size. Okay? These two matrices are the same size. Element by element multiplication. This will be multiplied to this. This will be multiplied to this. This. This and so on. Respective location of matrix will be multiplied to respective location of matrix, and then after all multiplication, the whole product will be sum. A sum of products. Okay, sum of products. And basically dot product is what? Element by element multiplication and then addition of all of them, right? That is also dot product. So we take a dot product of two matrices. This is convolution. But in convolution, what happens? I have two matrices. So a big matrix. So suppose instead of like this, I have a bigger matrix. Suppose this whole whiteboard is a matrix. Okay. And although most of the time this tiny matrix is square one, suppose I take this rectangular matrix as a matrix. What I'll do? This whole whiteboard is a big matrix. Okay. And assume it to be image only. This is the image. Barack Obama. And what I do? I take this small matrix. which I will call as filter. एक filter उठाया. It is still mathematically it is a matrix. I'm just calling it a filter. Why filter? I will tell you. So I took a filter, I put it over here, and through this filter I'm trying to find out something. So that something is a pattern, right? When I'm trying to find out, I'll take this matrix, tiny matrix, and the image is a big matrix. I will perform convolution. Convolution means element by element multiplication and then addition. So how big a matrix will be multiplied to this matrix? So this portion of my big matrix will be multiplied to this small tiny matrix like this. Now इसका result क्या आएगा? Single value. Let's say 4. Because I multiplied all those values and then added them together to find me a scalar value. Let's say 5, random. Then what I'll do? I will slide it from here to here. Then I will have next. Here. I will have, let's say, this other portion of big matrix that is being multiplied with this small tiny matrix and another value, let's say 5. Fine. In this way, I'm moving. यहाँ से थोड़ा सा और move कर दिया. यहाँ से हो गया. फिर थोड़ा सा और move कर दिया तो यहाँ से. और हर के corresponding एक scalar value मिलती जाए. और scalar value I'm storing 4, 5, let's say 10, let's say 9, something like that. और उसका पूरा फिर क्या हुआ? I would start from here और यहाँ से scan करते I will reach here. When I reach at the end of this horizontal section, I will start from here. एक row नीचे आ गए and I start from this portion, then again. और उसको क्या करेंगे? यहाँ नोट करेंगे 7, 9. Okay. So what will be the end result? I will have scanned the whole image. यहाँ से लेके ऐसे, फिर यहाँ से लेके ऐसे, ठीक है? तब scan कर. And I'm storing the result of that over here. So यहाँ पे, suppose not on this image, storing it separately, storing the value of that convolution. And suppose this is the filter. This is a filter. It's a matrix. What I'm trying to do is trying to find out a pattern. And that pattern says somehow I'll be able to find the pattern. A vertical arrow pointing upward. This is the pattern I'm looking for. ये arrow कहाँ बनी है पूरी image में? This is my objective. So I would scan like this, or फिर जब I will reach over here exactly, then I'll say, oh, I have found the arrow. How would I find that? अगर एक filter है, अगर ये है duster, और duster में, am I able to see through this duster? Not yet. लेकिन अगर मैं उसी arrow के size का एक cut लगा दूं इसमें, तब एक cut ऐसे बीच में और ऐसे ऐसे करके उसका arrow head बना दूं, तो I'll be able to see through this. और अगर मैं यहाँ पर रख के इस arrow को, I see through that cut, I'll immediately find that. मिल जाएगा ना? So through this filter, मैंने क्या किया? What I've done? I've filtered out everything that I don't want, but read only that slit. This type का. Since I have created a cut of this design, as soon as my filter comes to this region of the image, I'll be able to perfectly overlap and I'll be able to see through this. Okay. And suppose this arrow was there, so I was able to see through it. But there is no arrow over here where I'm putting the filter. Will I be able to see the arrow? Right? I will not be able to see the arrow here because there was no arrow. But there is a square circle over here, and I put my filter over here. Will I be able to see arrow? Right? So what happens if I look through this? What I will find? Looking through this, probably a small black portion over here and a small black portion over here, because these are the two cuts in terms of vertical line, and circle has two cuts. So what I'm looking at is a very small tiny portion of circle, but not an arrow. But when I put it over the arrow, I will find that whole cut from here to here is giving me black arrow shape. So I will indicate that portion wherever. I'll indicate that portion. So remaining will give me 0, 1, 0, 0, 2, 2, 1, 0, something like that. And where I find the arrow, probably it will be 100, something like that. Okay. So where I find nothing written, I find 0. Where I find very small portion of that I'm seeing, I will write 1 or 2 or something like that. Where I find the whole arrow, I will write a big number. Big number says that as per the sigma function, remember, if the input is big, the output is 1. If the input is closer to 0 or negative infinity, the output will be 0. ठीक है, as per sigma function. तो अगर यही वैल्यू मैं sigma function को दे दूं, तो for 0, 1, 0, 0, 0 वो 0 ही प्रोड्यूस करता रहेगा. और अगर 100 दिया उसे, तो क्या करेगा? इमीडिएटली 1 करेगा. तो मींस न्यूरॉन विल एक्टिवेट. राइट? So eventually what I'm doing, I have a big image and I take a filter, I see through that filter and I try to find out pattern. कहाँ पर वो pattern है? Wherever I find that pattern, I mark it like this. Okay. Here there is an arrow. Probably here there is a circle. Probably here there is another arrow like that. Okay. Now there are three things in this whole operation. One is the big picture, the bigger matrix, that is our input image. Okay, this whiteboard. The other one is the filter, this filter or the tiny matrix. Right? Third one is this output. Okay. I call it a feature map. I don't call it feature, I call it a feature map because I'm in a way I'm creating map. I'm marking all those locations where I'm finding something. यहाँ पे पेड़ है, यहाँ पे नदियां हैं, यहाँ पे woods हैं, यहाँ पे mountains हैं, all those things. So it's a map of all the patterns that I found through my filters. Okay, and this is how it, like you see over here. You understood convolution? Convolution is nothing but just multiplication of two matrices and summation from the elements together. If I take that process, let me have a filter like this. So my tiny matrix, this, it has a cut and it represents this kind of curve. Right? I can see through these. As I said, I can see through that duster. If I can see through this, I am seeing the other end. I take this filter and I put it over the image of this pretty mouse. And this is a big image. I take my filter, this is the filter, I take it and scan from here to here for this pattern that I'm looking for. As soon as I put this filter over this region, what happens? This 30 multiplied by 0 is 0. Again 30 into 0 is 0, 0, 50, 50. 30 into 50, something. Then this 30 into 20, 30 into 50, 50 into 30, 30 into 50, and then 50 into 0. But I get a very big number, 6,600, large number. Large number will lead me to a sigmoid value of 1. अगर ये large number मैं feed कर दूं sigmoid function को, तो it will give me 1. It will activate itself, indicating the pattern was found. ठीक है? But against this, if I take that filter, इसी filter को लिया and I put it somewhere else, and of course I put it over there because I am not able to find this pattern. So just to explain to you what is happening, and it's just multiplication and summation, nothing more. 30 into 0, 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 and all these values are again multiplied with 0, and the result is total null, right? So although the filter is same, the image is same, what this filter has told me that in this region, I was not able to activate the So I have an image, I have a filter. I'm scanning that image through this filter and marking all those locations where the pattern was found for this filter only. The same example goes with it. You have this filter, this is block, this is. If I take this and put it over here, from here to here, right? Here. This is white and this is green, means I need to have some value. So this is marked and this is marked, indicating that the pattern that I was looking for is foundable. This is another filter. It is looking for white and open, transparent and opaque. So this will be white and this will be black. So I take this and put it over here, from here to here, right? This portion, this filter has very successfully found it. So this is the portion where it found, it marked it. Move it ahead. So this is the portion, second pixel, take it over here, from here to here, it found, it marked. And again in this location, this is the portion, 2 white and 2 black. This is the portion, only portion. Other than that, there are no portion in which the filter has found actual pattern that it is. So what it has done, this is the big image, okay, input. This is the filter. Using these two, I have created a map. This is the result. And this map is called feature map. So I mark all those locations where the feature was found out. So same, and how do I find? By applying convolution at every location, right? So this operation is called convolution. We take a filter, we multiply it over entire area of input image. In this scheme, layers of neuron in a feed-forward neural network represent either the original image. Fine. Now, how does it relate to neural network? Yeah. Hyperparameter. How many filters you need to pick? Hyperparameter value, that again depends upon you. If you have a very simple set of images that you want to do, you don't need too many filters, like handwritten digital. Don't need too many filters. 32, 64, 4, 5 filters, 4, 5 conveyor, and let's start with 16, 32, then 64. You want to go 120, then come down. How people have done. First they increase the number of filters, then they decrease. Not hit and try. Again, let me again answer this question. It's never hit and try. How did I answer you? I said 16, 32, 64, 128, then I reduce it. It's a very unique number that I answered you. But how did I get to this number? No, again not. I have read it somewhere that people do. From literature only. A researcher should always talk in terms of the knowledge that he has obtained from some source. No random answer. Okay? From the book, and I will suggest that book. Actually, it's book by, forgetting his name. It's Deep Learning in Python. Orally book, no, not orally. It's Manning publication, and it's by and actually he's creator of Keras. So I'm forgetting his name. But that book very well describes why these patterns, why these features, filters you should take. What's his name? No, not Goodfellow. Goodfellow name. Only. He is creator of Keras. If you search creator of Keras, you will find his name. And his book is there. It's very good book. It types of it, right? So he tells. So it's from literature, right? From literature only, and from literature I take this number and I play with this number. I reduce, I increase, but I take it from it. Nothing, no more rocket science. ठीक है ना? So Here also, how many filters you have to take, that again your decision, but we make this decision on the basis of what other people have done. So that's a very good question. How many filters, right? We have to make this decision before we start creating the model. And number of filters decide the accuracy. Increase, have too many filters, the model will overfit and will take too much time. Decrease too few filters, will not get good accuracy. So again, our balance has to be created. Hyperparameter tuning is a big problem. It's a very big problem. That is why somebody was saying it's an optimization problem, right? We need to optimize what kind of hyperparameter we have to take. It itself is a research domain. People try to do research into how to tune the values of hyperparameters. That's many times we apply genetic algorithm, norm optimization, fuzzy logic to optimize or get the number of hyperparameters. But most of the time, the most practical is the regressive search, the brute force search. Yeah, because you would be doing research into your domain. You are not doing optimization of hyperparameter and tune that. So as soon as you get some kind of good values, make it a baseline and start from there. Right. So how do whatever I have discussed till now is only through visualization, a body matrix, a choti matrix, big matrix, tiny matrix, the filters, picture map. How do I map it onto neural network? This is how we map it. We have set up input neuron, right? We take a portion of this region of this input. How big a region? As big a filter. As big a filter you want to create, take that portion. Connect these input values to one neuron, which is, of course, input layer should be connected to hidden layer. One neuron. Now, these values are input, and the values on these edges, which we call weight value, right, will be your filter value. Filter में जो values थी ना, the value on edges will be filter value. And what happens in a neural network? The input values, these are X values, the big matrix. And you have got another small set of values which are edges. And you know, for every input there will be an edge. For every input value there will be an edge. So for every input in this matrix, there will be a value, corresponding value on the edge also. Okay. So I have got this matrix, the input, and another matrix W, which is on edges, and this value multiplied to this value multiplied to this value multiplied to this to this to this to this. Corresponding multiplication is happening, and after that, first you multiply WX, right, and then you add them. Somebody calculating neural network. ये क्यों करते हैं? So these are X values and these are values on weight. जितनी input, उतनी weight value, and all of them are corresponding multiplication, and then add them. Summation WX, we are doing the same thing, and then this summation WX is what we call as legit. में ये legit था ना, summation ही Z था ना, keep it with. इसके बाद हम क्या करते थे neural network? What when we calculate this Z, what we do after this? We pass it to sigmoid function, the activation function. Okay. In that case, sigmoid function was our activation function. Here I may choose to take another activation function. Here we will choose a ReLU function. Okay. So we pass this summation to the other part of composite function, that is activation function, the non-linearity, the function which introduces non-linearity, will pass it onto that. But up to this point, this is the, whether you call it a convolution operation or you call it a neural network operation, but it's a perfect mapping. So why did people started calling it convolution neural network? ये तो पहले भी हो रहा था, weighted sum तो हम neural network में निकाल रहे थे, right? Convolution operation का नाम की जरूरत क्यों पड़ी? Because convolution operation was defined previously before neural network came into play. This convolution was already defined. This was already an algorithm scanning the image, because a lot of different image processing tasks are performed by applying convolution. So in every image, convolution is a fixture that has to happen. But in neural network, we are doing what convolution does, but through neural network. So it became a convolution. Okay, combining two fields, which both were existing separately, and they were very advanced, but now they were combined together. So this is what is happening. The green one is the big matrix. The yellow one is the tiny matrix. And yellow matrix has this one, the red one are the values. Okay. So I take the small matrix and scan the whole big matrix, whole image like this, and store the convolution value in the feature maps. Now this feature map has become the next layer. Okay, the output of this convolution operation becomes the next layer. So much so that, suppose these are hand computation, you have an image and you have these filters. In mathematics, they are actually termed as kernels. The kernel is the small matrix that I'm taking. So I have this big image. I take k number of filters or kernels and apply convolution over this to get an output, to get a feature map. All right. So big input, small filter, and resultant feature map. So how many feature map will I have for the same input? As many filters. How many filters do I have? 4 filters applied on one input. And how many feature map? 1, 2, 3. Right? And same thing happens if I have, instead of 2D, I have a 3D network. But in 3D, what happens? The depth is always same. In 2D, in 2 dimension, this size is smaller, right? Smaller. I take this smaller and scan through it. But if I take the depth remains same. So this is my image size and this is the filter. This depth is 3. Here also depth will remain 3. I don't convolve in depth. I convolve in width and height only. So this is filter. Filter is multiplied with, so there are 27 values. There are 27 values, 27 value into 27 value, and then summation will give me a single scalar value. Okay. Yes, filter value or weight value. Right? In the neural network, when I was discussing in the previous class, how did we start with weight value? A random value. And then through training, we learned those weight values. Okay? Here also those weight values will be learned through training. So I'm not worried about how those values are coming. I'm just passing the buck to neural network. Neural network, while running and training, it will learn its weight values, and so my filter values will be adjusted. Okay.
Based on that, we can think of.
Not exactly on the basis of that. Yes, we are. Yeah, but no. We are actually neglecting some parameter because they are not important. Okay, they are not important, and that is again a tuning that we have to do. I'll come to that. When I discuss the step size, then I'll discuss that. Okay. Is it clear? So I have this portion of image, that portion is multiplied and added, convolved with this filter, and then a single value is obtained. Now, if I have this whole image, you should appreciate that I have taken 1, 2, 3, 4, 5, 6 filters. For every filter, when I apply this filter over this input, I get a feature map slice. So this is the output layer that we get. Previously, we were getting a 2-dimensional or single-dimensional output layer, hidden layer. Sorry, not the output layer, the resultant layer. Resultant layer over here is another hidden layer. So this layer, when converted over by 6 filter, will result in a resultant hidden layer that has 6 slices. 1, 2, 3, 4, 5, 6. Courtesy to 6 different filter applications. So as many filters you apply, that would be the thickness, depth of the output result, right? Okay. Each filter corresponds to a slice in the elliptic. Now, there are some hyperparameters that you need to tune. The spatial extent. I told you, no, if I take this filter and I start from here, I may choose to move it this step, then this bigger step, then this bigger step. That's my choice, right? Or over here, suppose this is the portion at which I started. Since I have scanned this portion, I can choose to scan from here after the scan portion. So I will scan it like this. So scanning will happen like that. So once a region is scanned, it will not be scanned again. Or I can, instead of this also, I can take a bigger portion. I just skip it. Portion I have skipped. I scan this. But is it advisable? No, this is not advisable because this portion you are not looking at. Probably the image and pattern that I was looking for is penetrable. But this is again our choice. And as you said, this portion we are neglecting, right? So we have to tune how big a size, how big a step size we have to take. And that is the stride. How big a step, how big a stride I should take. That is the stride. A spatial extent. What should be the size of this filter? How big this filter? That is again a hyperparameter we have to understand. Depth. Depth means input is given to you. The output depth is decided by number of filters. Right? So how many filters you apply? That constitutes depth of output. So how many filters? That is also a hyperparameter. All these are things that you have to adjust, to modify, to understand how good is your result. Otherwise, अगर कुछ रहेगा नहीं तो फिर research क्या करेंगे? है ना? These are the things that we do in research. Padding. What is padding? Padding means, suppose I have this filter, okay, and this is a workable filter. I have some pattern over here which is very important at this corner. Why this pattern? Can you give me an example why this corner pattern may be very important? Edge. The information is on edge. Any example? You are scanning an image, and some important information is in a very corner of that image. Suppose I'm trying to identify an incident has happened, and I'm trying to identify the culprit. Okay, and in very small screen video recording CCTV footage, I find that okay, there is a person who is at the very corner of this image. But when I'm scanning through this filter, how many times will I look over this portion? One. एक बार यहाँ रखा और फिर क्या किया? आगे बढ़ गए. I reached over here. I left that portion. So what was my attention span? Very small. One scan only. और अगर नीचे भी आ रहे हैं तो इससे नीचे से शुरू किया, यहाँ से किया, तो that is gone. लेकिन अगर किसी input image को if I pad it, यहाँ पे कुछ values दे दी, fictitious value, यहाँ पे कुछ value दे दी, तो क्या होगा? I will start from here, right? So this portion will, instead of being at the very edge or corner, will be somewhere over here. हमने padding कर ली, इतनी padding इधर कर ली, इतनी padding उधर कर ली. I'll start scanning from here. यहाँ से scan करेंगे, ऐसे scan किया, ऐसे scan किया. तो जब यहाँ पहुंचे, क्या कर रहे हैं? Suppose यहाँ पे पहुंचे और हमने इसको scan किया, ऐसे scan होकर एक बार गया. फिर यहाँ पहुंचे तो एक बार इसके दूसरी बार scan किया. फिर यहाँ पहुंचे तो ये हो सकता है हाफ में तीसरी बार scan किया, right? और जो ऊपर से नीचे आ रहा है तब भी scan करते जा रहे हैं. So that how much importance you give to the overall image. That also tells you how much padding you should do. Okay, suppose you are just identifying field और field में आपको boundaries identify करनी है. On a agriculture field, you just need to identify boundaries. तो वहाँ इतने pattern की जरूरत नहीं. You don't need to do too much of padding because that is the wastage of computational resource. तो वहाँ हम इतना padding नहीं करते. But if you have to identify each and every face very uniquely, then I need each and every pixel of position very uniquely represented. उसका हर बार attention उसको मिलना है. Alright. Spatial extent means size of this filter. This filter का size कितना बड़ा होगा? Normally we take it square because जितना length है उतना width है, so it can be represented with one value only. Suppose I say 2 means pixel, its filter size is 2 by 2. Okay. So spatial extent is a parameter receptive field size or filter size. Huh? E is equal to filters height and width. And we many a time we take it as an odd number. So if it is 5 by 5, then there is a predefined, very defined center. Okay, third from top, third from left is the center of that receptacle size. So this is also, it should be square and it should be odd numbered receptacle size. Okay. Input depth is the depth of input, right? Whatever input. Output depth is defined by the number of filters that you take. Stride is the step size, and padding, as I told you, we pad the input so that we pay more attention to the location we are actually trying to look at. So can I give just open this link? Open this link. It should be with labels. CNN is most of the time is looking for label target. What am I looking to look for? See, as I told you, first you need to classify, first you need to categorize. What is my job? Am I looking for classification? Am I looking for clustering? Okay, so level is defined, predefined level. Labeling is not there, and intensity value is also not defined. Okay, then at that CNN is working for classification or regression, right? Supervised learning. First of all, it is supervised. If it is supervised, you can have some flavor of unsupervised only, but CNN mostly for supervised. You need to give it a target. If there is no target, then it will not be able to train itself properly. Because every time I'm saying that it needs to learn this filter, it needs to learn the weight values. It will learn those weight values on the basis of target only. So if there is no target, it will not be able to learn. First. So if your data set does not have this intensity value, somehow manually you need to create these values. And this is a big challenge. In deep learning, this is also a limitation that you need to find out proper data set and ground truthing of that data. Ground truthing means first you need to create the actual label. So suppose I have some kind of problem and you need to measure my intensity, then you first need to define my intensity. If intensity is not defined, the neural network will not know. Okay. So if target is not given, this is unsupervised learning. Unsupervised learning will give you a cluster, but it will not classify or it will not give you a unique value. Unique value is regression. Okay. So what you are looking for is basically a regression, and that too, if you are limiting it bounded by something, so regression converted to classification. What is intensity value? Yeah. And you would be categorizing it into 0, 1, 2, 3, something like that. Fine. So for that, you need to give it a target. And for that, you have to define the target yourself. Suppose your problem, you need to sit with a domain expert doctor and you need to understand. Let's say nephrologist. In nephro, we identify what is the creatinine level. So depending upon creatinine level, depending upon GFR value, we have a map of how big a creatinine value should be there, how low the GFR should be, that indicates to a seriousness level. Okay. So these two terms, they have a whole matrix of it. So creatinine, increase of creatinine is bad, decrease of GFR is bad. So when you merge them, you find out what is the danger level, what is the severness level. That can only be told by a domain expert, doctor. And after identification of that, you can train the neural network according to those tasks. Otherwise, it will be.
Signal can be like signal is like one-dimensional data. Can be programmed.
If it is like that, if you have a regular signal, it's a matter of finding the pattern, then we can find the pattern. Okay, but then what target are you going to provide? So what happens most of the time, what we do, you train it to some pattern, classify some pattern, and then remove the output layer. Okay, remove the output layer. In the final layer, fully connected layer, you have a whole what do we say? Kind of feature vector of the signal, because your signal will have huge amount of value, right? So all those value will most of the time will not be useful. Convert that into a feature vector, that is the final fully connected layer. Remove the output layer and treat this fully connected layer as an input to find out the pattern. Okay. Probably after the lecture we can discuss that. Okay. So here what I was trying to explain, you see, there are three filters, all right, and this is one image with RGB value. So this is 0, 1, and 2. So 0th layer, first layer, and second layer. So RGB, you can expect it like this. And with all, you have got three different single filter, but depth is also 3. So 0th, 1th, and 2th, and bias is 1 over here. Fine. So this is one filter, filter W1, W0, and this is filter W1. So two filters are there. And this is the output volume. So for this filter, this is the output you are getting. For this filter, this is the output you are getting. Now in this, same parameters of filter are being used. What are parameters? Parameter are the weight values, right? We are trying to learn the weight value. One filter corresponding to 27 values over here, and these 27 values from here to whole image is scanned through these 27 values only. Chitna bada image, howsoever big this image is, the whole image is scanned through 27 values. One filter is done. Again 27 values. So you need to learn 27, only 54 filters, 54 parameters, and with 54 parameters, you can, these parameters are being shared. Whatever parameter these 27 values are there, from here to here to here to here, the whole image is being connected with those values only. They are not changing. With the change in location, they are not changing. Had it be a regular fully connected network, जैसा हमने पहले देखा, previously artificial neural network, ANN, in that the parameter were not shared. As soon as the location change, these values, the edge value will change. So over there, you will need hugely many parameters to learn. But through CNN, the parameters are being shared, and the number of parameters that you need to learn drastically reduces. So there are these are the layers that mostly we have in convolution layer. First layer is convolution, second is activation function, then fully connected and drop-off. You have worked, you had a hands-on, and you have created these layers. What are these layers? The convolution layer, you all understand. When we call conv layer, you need to define what will be the size of your receptive field. Okay, the size of filter. How many filters you will apply in the conv layer? What will be the step size? Step size kya hoga? These you need to define. Okay. But after defining them, what will I get? Summation WX. What I will get? This summation WX need to be fed to an activation function. For that, we need activation layer. So after conv layer, there is an activation layer. After that, there is a pooling layer. Pooling layer is there to reduce overfitting. If I teach too much of information to the neural network, it might overfit. So what we do some kind of make it learn less by removing some information. How do we remove information? Let's say so suppose I'm doing a max pooling, okay, and max means the most darkest color, let's say, represents the max value. So I pick 4 pixel, and out of these 4 pixel, I pick the maximum value. And in this case, suppose darkest represents the maximum value, I'll pick this and I keep it. And then over here again, I have all white, so I'll have no choice. I'll pick the white. When I reach over here, the darkest one is gray one, so I pick the gray. And over here, I have the darkest as black. So out of 4 pixel, I have ignored 3 pixel and kept the value of 1. And you understand, images are very large. It's not important that all pixels will have meaningful value, right? So we can choose to ignore some data. Of course, it leads to data loss, but that is acceptable. I don't want this much information. So information is reduced. Instead of having 4 pixel, now I have 1 pixel. So 1 by 4 information is passed on. So I pooled this information of 4 pixel into 1 pixel, and that is my function. This is called pooling layer. The pooling layer performs this operation. And if it is depth pooling, then depth will not be reduced. Depth is not reduced because depth is created because of various filters. It's only height and width which is pooled. So out of these, 6 is passed. Out of these, 8 is passed. Out of these, 3 is passed, and out of these, 4 is passed. Okay. So we are basically doing a downsampling. So out of in horizontal, if I look at out of 2 pixels, I picked 1. So out of 2, I have only 1. Here also I picked 1, so 1 pixel. So I am downsampling, making it half in terms of width and height both. So whatever image was there, it just gets pixelated, more pixelated. But that is what I need. Now, what is fully connected? Fully connected layer is totally fully connected. All the neurons of one layer will be connected to all the neurons of next layer. Dropout. We apply dropout layer between 2 fully connected layers only, nowhere else. Why dropout? Because dropout is actually another way of regularization. Dropout is another way of regularization. Here, what we are regularizing? We are asking the neurons not to learn too much, but to learn too many things. Too many things. Learn being jack of all trade, but not master of anything. I want my neurons to be jack of all trades, but not master of anything. So what is happening? How is it happening? I have these layers, let's say fully connected. Okay, all neurons of this are connected to all neurons of this through this layer, and I put it over here because I assume this is my dropout. So what I'm doing, I'm through dropout. What I'm doing, I'm applying, let's say 50% dropout. What does it mean? Randomly out of these neurons, I'm switching off 50% neurons. Okay. So I pick this neuron, I toss a coin. And tossing a coin, what is the probability of getting head? 50%, right? So I toss a coin. If I get head, I will keep it or I will switch it off. So it's just like a switch. When you switch off a switch over here, does it happen that all the lights are dismantled or AC ukhad ke leke chale gaye? Doesn't happen like that, right? Switching off means for that time period when the switch is switched off, those appliances are not working. So it is still present, but just not working. So this tossing coin gave me head, let it be here. Tossing coin over here gave me tail, switch it off. Iska output nahi niklega. Again this tail, switch it off. This head, head. So if there is no output from this neuron, तो इससे कोई एरो नहीं जा रही है, इससे एरो जा रही है, एंड दिस न्यूरॉन इज ओनली गेटिंग इनपुट फ्रॉम these three, right? So what is happening? This neuron is learning to live without these, learning to live without these two. How is it learning? Every time, whatever, whether you have these neurons or not, हम उसका एरर बैक प्रोपोगेशन तो कर रहे हैं ना, एरर को बैक प्रोपोगेट कर रहे हैं, और ग्रेडियंट डिसेंट हमेशा उसको लोअर एरर की तरफ पुश कर रहा है ना, ठीक है? So whether these two neurons are present or not, the neural network is reducing its error. So what was the use of these neurons? If still it is learning, was there any use? No. So can I totally remove them? Yes, we can. But how do we? Because we do not know which neuron is actually working, which is not. That is why dropout is there. Randomly. Next time, these will not be switched off. Probably this might be switched off because it is tossing a coin, 50%. Okay? So who knows which neuron? But all of them are learning to live without other neurons. So they are learning everything. एक टीम है जिसमें कभी किसी को छुट्टी दे दी, कभी किसी को छुट्टी दे दी, लेकिन काम तो सबको करना है. Those set of tasks are to be completed. तो अगर मान लिया कि हमने छुट्टी दे दी, किसी एक फैकल्टी को छुट्टी दे दी, तो rest of the faculty have to teach this course. So everybody should know everything. But it may happen कि एक ही बंदा है, वही उसका एक्सपर्ट था. अब हमने कोई एक्सपर्ट, सारे एक्सपर्ट मार भगाए, अब सबको बोल दिया सब कोर्स पढ़ाना है. तो मैथ वाला साइंस पढ़ा रहा है, साइंस बायो पढ़ा रहा है, बायो वाला हिस्ट्री पढ़ा रहा है, हिस्ट्री वाला जियोग्राफी पढ़ा रहा है, पूरा क्या क्रिएट करना है, ठीक है? सो दैट नो वन लर्न्स टू मच, कि बहुत स्पेसिफिक न्यूरॉन नहीं बनाना. It should be generalizable. At any point of time, every neuron, suppose this neuron is there, it should be able to predict probably 7 also, 8 also, 6 also. ठीक है? This neuron 1 also, 2 also, 3 also. तो अगर मान लिया कि हमने यहाँ पे बहुत सारे एक्सपर्ट्स क्रिएट कर लिए और ये आप कह दिया कि एक बहुत बड़ा पूल बना लिया जिसमें हर कोई हर कुछ जानता है, तो आई विल डू अ वोटिंग, और वोटिंग इज अ स्ट्रॉन्ग क्लासिफायर रादर देन वीक क्लासिफायर. वीक और स्ट्रॉन्ग लर्नर्स का डिफरेंस पता है ना? वीक लर्नर एंड स्ट्रॉन्ग लर्नर. यू नो एंसेंबल लर्निंग, रैंडम फॉरेस्ट पढ़ा है ना? रैंडम फॉरेस्ट में क्या करते हैं हम? बहुत छोटे छोटे डिसीजन ट्रीज बनाते हैं, राइट? बट रैंडम फॉरेस्ट इज अ बेटर एल्गोरिथम देन डिसीजन ट्री. डिसीजन ट्री एक ट्री बनाया, वो ओवरफिट कर गया, पूरा एल्गोरिथम ढह जाएगा. बट रैंडम फॉरेस्ट क्या है? छोटे 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 बहुत सारे ट्रीज हैं, थाउजेंड्स ऑफ ट्रीज. All those are weak learner. What is a weak learner? उसका output will not be any better than a random guess. A weak learner is a learner whose output is no better than a random guess. आप random guess कर लो, वो weak learner जैसा ही result देगा. But there are so many weak learners combined together and vote, majority voting करके एक strong learner बनाते हैं. Ensemble learning यही है और कुछ नहीं. All these are weak learners, but they combine together to create a strong output. और the result that they provide is much better than कि उसमें एक एक्सपर्ट हो जाए और बाकी सारे बैठे हुए मजे में. टीम में एक बंदा काम कर रहा है, बाकी कोई काम नहीं कर रहा है. We don't want to create this kind of situation, है ना? हमारे पास भी स्टूडेंट आते हैं ना माइनर प्रोजेक्ट करने के लिए, जैसे आप लोग भी जाते हो. 10 की टीम बना ली, हमें पता है उसमें एक ही तो काम करेंगे, बाकी 8 आराम करेंगे. We don't want that kind of system. We want टीम का ग्रुप बने, all should learn. ठीक है? That is what we push it. That is dropout. Dropout pushes them to learn. Yeah. Pruning in case of decision tree. Pruning happens in which algorithm? Yes, it is similar. But when we do pruning in decision tree, there we explicitly see the pruning of which branch is actually leading me towards no loss of error. ठीक है ना? We do selective pruning. Here we are not doing selective, it's random. Random dropout. Any neuron can be selected randomly to be switched off. But pruning is very specific. We learn which to prune, and once pruned, that is gone. Here it stays. It stays. It's not gone. For the time being, it is not in the process of learning. But next epoch में क्या होगा? हो सकता है इसको switch off ना करें, इसको switch off कर दें. So it will learn in the next epoch. It is still part of the system. It is not pruned out. Okay. So this is the layer pattern. Normally we look when we create CNN, you start from input, then you have conv value combination. Okay, you repeat it as many times you want, and mostly 0 to 3, and then pooling. You choose whether you want to have pooling layer or not. That's your choice. Okay, there is a question mark. And this combination you can have as many times you want. M greater than 0, as many times you want. Okay. Then after repeating, you have fully connected to relief. Of course, fully connected also need to have an activation function. ये भी आप एक दो बार रख सकते हैं, ये between 0 to 2, और इसी के बीच में ड्रॉप आउट लगता है. ड्रॉप आउट इज ऑलवेज बिटवीन टू फुली कनेक्टेड. ठीक है, कॉन के बीच में ड्रॉप आउट नहीं लगता, because conv layer is just identifying the pattern, it is not connecting. Okay, so AlexNet has got this input layer, then conv value and pool combination repeated 2 times, then conv value combination repeated 3 times, then a single pool, then FC value and dropout 2 times, and then softmax. Okay, what is difference between softmax and sigmoid function? Binary value. And what about sigmoid? Softmax also gives 0 to 1. It's a real number, not a binary number. Softmax doesn't give binary number. It also gives probability value. And 0 to 1 is also probability value by sigmoid function. Anyone else? What is difference between softmax and sigmoid function? Softmax, sigmoid gives 0 to 1. Fine. Sigmoid also gives 0 to 1. But suppose there are 10 outputs. Okay. So the value generated by them, if it is generated by softmax function, will add to 1. So it actually gives the probability, and all probability should add up to 1. So if some value is, let's say, 0.9, the remaining will be so small so that they add up to 0.1, so that the total sum is 1. That is why we apply softmax at the output layer to get the maximum probability of one value and per classification. Okay. And sigmoid has no this kind of restriction. It just gives 0 to 1 whatever. तो ऐसा हो सकता है कि sigmoid अगर हमने लगाए तो multiple 0.9 निकल के आ रहे हैं, उनका sum 1 नहीं होगा. That's the only thing. Okay, that's it from my side, and you have already seen the implementation. Yes, please. These are the values. I mean the filters that we apply. Wherever you see filters, actually filters वो edge पे ही रहते हैं, right? तो वो जो matrix है, those are the weight values. And when we propagate the error backward, so all these edges get modified. When we perform the back propagation, all edges weight values get modified. And when they are getting modified, they are leading towards lower gradient descent as per lower error.
कर्नल का वैल्यू
होता रहता है. कर्नल ही है वो जो हम लर्न कर रहे हैं, है ना, वही है. कर्नल का वैल्यू चेंज होगा. और I had some probably I don't have this in my slide, but if you visualize, did you find out who was the creator of Kriyas? Francis Cholet, yes. So he has written this book, and his book is this one, Deep Learning with Python. Yes, you read this book. It's a very good book. In this book, they have described. This is the book I was talking about. You read this book, probably a new version has come up. Deep Learning with Python in 2021. It's a very good book. You read it from page to page, you would love it and you would learn keras automatically. इससे ज़्यादा कुछ नहीं चाहिए. So in this book itself, he has given a lot of pattern. How these features identify the pattern. एक cat की image को लेके, how that cat image is being transformed into different images, और finally वो एक pixel में, single pixel में कैसे convert होता है. It's a very good example. You look at it. Cats and dogs classification at Kaggle. Had I been doing this workshop, I mean hands-on, मैंने वो कराया होता. Cats and dog classification through keras. So in this you identify a cat, take a cat image और उसको segregate करते finally एक pixel मिले आपको. That one pixel indicates cat or dog. So that's it from my side. Any question?
Anybody having any doubt?
I think everyone has already asked sufficient question, right? And apart from it, of course, once you do it, then you learn it. Okay. And you need to apply it. So it's a very good book. And if you want to learn deep learning, it teaches through keras because he has invented keras. Keras is the library file, a library created on top of wrapper function created on top of TensorFlow. It's very useful. Learn through it and you will get to understand so much. Thank you. See, it's kind of a capacity of the brain, right? As many hidden layers there are, those many parameters, and those that much information you can learn. But then for a smaller set of problem like handwritten digit recognition, or you have to identify between cats and dogs, adding too many hidden layers will lead to overfitting. Fine. So it's not as tough as probably I am sounding, but there are certain, but to answer your question in one sentence, more hidden layers means more capacity to learn. That's it. Okay? Because you are introducing more parameters, and parameters are the memory. Fine. No, not these parameters. We try to reduce the dimensions of the input. That is dimensionality reduction. These parameters, we try to have more parameter because we want to learn more. But suppose the problem is very small, right? Only binary classification between two classes. Then you don't need a big, huge network. That will lead to overfitting because a lot of new. See, I need to differentiate between a pen and pencil. एक बहुत छोटा सा portion of दिमाग use करना पड़ेगा. लेकिन अगर पूरा दिमाग में उसी में लगा दी, if I whole mind, whole network is devoted to learning it, it means it was a task of one neuron, and I'm training all neuron to do it, right? So all neurons, and particularly that neuron, is learning too much again and again and again every time. So a small task being repeated again and again, so it is overfitting. A single pencil, single pen, whatever input is being trained upon, the model has overfitted on that. So reduce. At that time, if the problem is simpler, reduce the size, reduce the number of hidden layer, reduce the number of parameters. If the problem is large, suppose you have to identify celebrities, okay, or face detection or face recognition, you have multiple classes, hundreds of people, thousands of employees, okay, then the network should be larger so that it could remember every face clearly. Fine. At that time, you need higher capacity, so you need a bigger network. Okay. So if the problem is complex, you need to create a more number of hidden layers. If the problem is simple, reduce it. Thumb of rule, if I am able to do it easily, neural network should be able to do it easily, so a smaller network. All of them have same functionality. Yes. Most of the time, what they do, they increase the size like this, go to center, and then try to decrease. But that is also aesthetic requirement only. Okay? No practical value. You can keep the size of all hidden layers same. 256 neurons in all hidden layers, 100 neurons in all hidden layers. Doesn't matter at all. Or you can keep increasing 100, 200, 300 like that, and then keep decreasing. All aesthetic, no practical sense behind that. It's all what matters is how many connections there are. As many connections, as many parameters, right? As many parameters, that much a learning capacity. Neural network does not differentiate between hidden layers until it is doing something else. Okay. If the functionality is different, then that is another issue. Otherwise, it doesn't differentiate. But at that time, it creates big problem. करेगा, लेकिन sparse set means I get the useful information very sparsely. Then somehow we need to have more advanced mechanism. We need to squeeze the input so that the actual information gets more focused. But where do I find actual information? अब हर image को बैठ के तो अगर हम उसमें circle करते बैठे तो it is very tough, right? So we need more advanced mechanism to first deal with the input. So somehow we need to reduce the dimensionality of the input. So sample को ही reduce करेंगे, such that information is highlighted and the sparsity is reduced. Then only, yes. I don't think CNN will be helpful over there if we have sparse. First, we need to reduce the sparsity. Definitely affect. First, you need to balance it. To balance, like you see, what we do in boosting. In boosting, any sample which is being categorized incorrectly, we increase its number. Okay. Writing disability, like writer's cramp, etc. Yeah, you will find very less sample of people who are having this problem. So if you have samples, then that is fine. Try to augment the data. In that case, you can apply data augmentation. Repeat those samples. Suppose you have fair writers versus poor writers. So increase the number of poor writers, just duplicate them. It should be balanced. Because if some pattern is being taught again and again and again, the model is also like that. And it assumes that, okay, these patterns are used with probably noise. I don't need to understand them. I don't need to remember them. Okay, so 1000 versus 2, 1000 versus 6, 1000 versus 10. So these 10 will be ignored. So you have to balance them. Balancing is a problem, I understand. But then the balancing has to be done. You duplicate them. But then duplicacy means, suppose you have 10 samples only and versus 1000. Duplicated 10 means this will overfit. And again, if I'm instead of 10, I'm getting 11th one, it will not recognize because it has overfitted all these 10 samples only. It's a problem, but yeah, can't directly give you a solution for outright solution right at this moment. Any other question? Chalo, I think we can talk separately.
Okay,
also.
so thank you so much, sir, for your insightful discussion, and we can say the nice lecture. I hope this will helpful for all the participants and with us also, sir. So may I request Dr. Anurag sir to please felicitate Dr. Ojha sir to with that token of gratitude, sir. Sir, please. Okay. Okay, thank you, sir. Sir, please.
So, heartily thank you, sir, for joining us here. For it's directly from Triple IT Allahabad. You came here physically and delivered this talk. So, I hope this talk, this insightful talk and very informative talk, would be helpful for all of you. You know, CNN we usually take whole semester to teach. You know, and sir, I just squeezed it within 3 hours. So, and it was very interesting, I guess, and hopefully connecting to yesterday's hands-on session, you might have got something which could be helpful for you, for your research career. And as I've told that it's just like a thoda, just like a tool. So it's specifically this workshop was designed for healthcare application, but yes, for specifically we were focusing on developing tools. What are the different tools available to handle this healthcare data, biomedical data, and this is the best tool right now in the market, which is evolving, which is very popular. So hopefully this lecture would be helpful for all of you, and you will use it somewhere or other in your research career. Thank you, sir. Thank you once again. So we'll close this lecture here, and I think after this we are having break today, right? It's a local tour today, So for today, I think my Prakash, these are our local volunteers will help you to explore the local things. I think this Muktangan is very nearby, and right now in view of the G20, it is being decorated, and it's a clean, and it's a best place to visit right now. Very in the close vicinity. It's a I think picnic, you can enjoy picnic there and going in group and enjoy there. It's very nearby, hardly less than a kilometer. So you can just go by walk also, and nearby other places. I think you can take help from them. They can give you some other, like our jungle safari or zoo is there, our musical fountain are there. So nearby things you can explore today and feel relaxed after having this going into deep for this deep learning lecture. So keep your mind a little relaxed. For then we will meet today at, I think, tomorrow session at 10 a.m. Okay. Thank you very much.
So just a very small announcement. For I am circulating this sheet. Your name is written there. So just check your name. If anything you want to correct, because this is for the certificate. Okay. So if any correction you want, just write it. And if you want the correct one, just take the right. So just please sir. Simultaneously, I am suggesting you that for the local tour, that Muktangan is very near, I think 500 to 700 meters, and the Prakash will be for the Muktangan. Those who want to go the Muktangan, Prakash is there. But if you want to go the zoo, then by on you may go. So it's just a 2 kilometer from here. That bus is also there if you want to go. And I am recommending you better to go with the Prakash to Muktangan. If anybody don't want to go the Muktangan, then you may go to zoo also. Okay. And those who want to go the Raipur also. उसके लिए कोई restriction नहीं है. Those who want to go, it's just a free thing, not the fixed one. Everybody should have to go the Muktangan, should have to go the. So यदि मुक्तांगन जाना है तो प्रकाश will be there. कितने बजे आएगा? 2:45. He is here. Okay. Muktangan having the tribal heritage site. Just like this is a tribal estate. So here the so much heritage site is there. Heritage tribal thing is there. No, I have you better. Yeah. Okay, means futures. Like you are, if you want to. It's needed for our. Okay, so आप जा रहे हैं आप जाते हैं one more thing आओगे नहीं ठीक नहीं देख
You can check your name. If name is short form, you can. If you want to use the full form, you can use. In case of name is correct, you can tick. Otherwise, if incorrect, you can write proper name. Okay. Only name column you have to check only. Rest of the for our information, you can check name column only.
Okay. For the certificate, only you need to check this column for the certificate purpose. If you have you got the correct one, just take here. Otherwise, you write the correct one. Okay. So just circulate. And I think the 140 is there. 140. So 245. 245. Present here if you want to go the और जिसको नहीं जाना है जितने आ जाएंगे 245 तक जितने आ जाएंगे 245 तक व्यू में वो अदरवाइज जिसको रेस्ट करना है रेस्ट
Good or not? It's smiling. Look here or your side. There. Thank you.
ये सीधी कर हो जाए
सर वो प्रॉपर चेक कर लेना अभी सर हाँ ये
In front of this room, if you want to go the Mustagan in front of this room to around 240, you all are present here. Those who want to go the Mustagan, those who want to go the Raipur, you may go. Those who want to go the zoo, you may go. Okay.
only day, sir.